This conference will now be recorded. This conference will now be recorded.
So hello everyone, welcome to day 12 in our GCP Cloud Architect training. So where yesterday we saw some cool stuff, some slightly advanced topic in Kubernetes where we learned two different styles apart from the GUI. So in command line itself, the imperative configuration where you have to remember the commands and you just mention this is what I want. Like you need to mention everything in the command there. So the other option which we saw was a declarative option where it was more of a configuration, and the configuration can be tracked very easily with a um, source control system like GitHub or Google. GCP has its own version control system, which is cloud source repository. So we saw that, and afterwards we slowly started exploring some more concepts. Somehow, after looking into the declarative approach, which is the best approach, we started exploring about deployment, replica set, and pods. And I also mentioned replica set is not now extensively used. Pods or deployment, and pods are not self-healing. So if you just delete a pod which does not have a part of a deployment, it cannot be recovered. But if the pod is part of a deployment, it has its self-healing capability. Is there a question? Okay. So it has that self-healing capability, and I had shown you yesterday in the command line where I deleted a individual pod, and what happened? It was not able to recover back. But a pod which is part of the deployment, even if you delete, if something crashes, the pod comes up because you have mentioned what is your desired state there. So that's a very important thing, the self-healing capability. And this is an image which I did not create it. I got it from internet. It was really good, so I thought let me put that. So let me show you one more time the self-healing capability via UI. So it's the same setup which we had. So we have one deployment object, we have one pod object. So if I go inside this deployment, I will see those pods. So I see the deployment details, and if I scroll down, I see the replica set, and I see the pod. So I have only one pod running. So what I will do is I just go to this pod. Uh, can I do it here? Yeah, let's try to do it here. So I'm just going to delete my pod. So let's see what happens. This is part of a deployment. So if I delete this pod, because it is part of a deployment, it has a self-healing capability. So it's going to go off, and a new pod is going to come up. You see this? A new pod is coming up. The older one is going to go off because it was deleted by us or accidentally it was crashed, whatever it is. So one is terminating, the new one comes up automatically because you have mentioned it in the configuration saying that I want one replica always. So that's your desired state. So this is the cool feature of a deployment. But when it comes to a pod, you just delete it, it goes off. That's it. Let me just try deleting this pod. So let me try deleting this pod. The moment I delete it, nothing is going to happen. It's not even going to come back. It's not going to even come back. After terminating, it's totally going to be the entry is going to be totally removed from the cluster. Let's just wait for this to come up. So once it is terminated, gone. It's not going to have anything further. So let's just leave for a minute here for it to remove that list
So
entry.
Mahesh,
That's it, folks. It does not. Yeah. Yeah,
so
Anil Kumar.
the
Yeah.
parts will not recover, but the deployment will recover
Correct.
when the deployment is deleted.
Correct. Correct.
Okay.
Deployment, no. Deployment, if you delete it, gone. Deployment, you should not delete it. What I deleted was the pods inside the deployment. So that is what I deleted. So if I delete the deployment, that is also going to get deleted.
No,
Entire
no.
deployment you are
If you
deleting.
go into the
So
if you
the
go into
pods
the
inside the
deployment,
deployment, if you delete it, yeah. So deployment, and this deployment has one pod, so it has one replica set and one pod. So if I delete this pod, it is going to recover back. It's going to recover
okay.
back. So small concepts, but sometimes when we are learning for the first time, right, you will get confused. What is a pod? What's a deployment? All those things. So just wanted to make it very clear. And I went through this cycle, so I don't want you to go through the same cycle of getting what it is. So that's the thing. So now I just deleted my pod, right? And the pod, every details was mentioned yesterday. We had created it using our super tool, which is the Cloud Shell editor. Am I here? Yeah, Cloud Shell editor. So which created most of our YAML files yesterday. So today, what we will do is, so I may, yeah, this should be good enough. So now if I see, if I, yeah, because I may need that pod for some other demonstration. So I'm just going to recreate it, folks. I'm just going to recreate it. kubectl apply minus F. I'm outside the folder, so I'm going to go inside this and mention it. So the pod is going to be created. I have to do it like this, recreate it. Since you deleted it, there's no self-healing capability. You have to explicitly go and create it. Now, that's on deployment, replica set, and pods. Now let's try to understand some of the specifications, replica, then strategy, maximum search, image pull policy, all those concepts, right? This is very important. I have seen at least in the exam something on image pull policy, strategy kind of stuffs. Uh, Questions are related to that specifications, the configuration which you write in those YAML files. So how do we understand it? The tip is very, very simple. So you may look into kubernetes.io documentation, you may get the complete picture. But if you feel that is a little vast, the simple tip is open your YAML file in the Cloud Shell editor, specifically in Cloud Shell editor. I don't know about any other editor which works like this. Maybe Visual Code can work, I'm not very sure. But I saw this one and it was very handy. So let me just show you how this works. Basically, we are trying to understand the configurations. Okay, so for that, let me launch my Cloud Shell editor. I would say I became a fan of this editor. That too after seeing yesterday's stuffs. So now let me just open my deployment.yaml file. Now, for example, you don't know what is replicas. Now, simple. You just mouse over on it. It shows me that tip, replica, a number of desired pods. This is a pointer to distinguish between an explicit 0 and a default is 1. So meaning when you create a deployment, if you forget to mention this value, the value is going to be still 1. You are going to have one replica. That's the indication. So then you have selector. You just mouse over on it, it gives you that complete picture. So this is like either going through the documentation or only seeing the values which is important for you. Value for you. So similarly, if I go to kind, it's going to show what kind of object it is, and the complete details of that is mentioned in this documentation. Just click, you will get it. The one which is important for us is okay, here it is no replica, maximum search, nothing is there. Let me try to put that, or let me open up an existing configuration which I have and compare it with this one and the other one. So if I just go open one existing configuration, this is another existing configuration which I had. So where I have few slightly extra components, strategy, and under strategy, what is the type of update you are going to do. So if I just mouse over on strategy, it shows The deployment strategy to replace the existing pod with a new one. What is the strategy? That you have two properties only. One is rolling update. So you will have little zero time. You'll literally will not have any downtime. So the existing pod is going to be there till the new pod comes up. The existing one is going to be there. The moment it comes up fully, the old pod will start deleting. So that's your rolling update. The second type of option which you get is recreate. It's completely delete the old one and you create the new one. Recreate. You have two options, and the default one is rolling update, folks. Meaning, in our configuration, we don't have the specification itself, the strategy. Meaning, even if you don't mention it, the strategy is going to be rolling update, is what it indicates. Now, how do I add it in my YAML file where I don't have mentioned it? No problem. Just hit type sorry, let me make a mistake. So I don't know how to do the spacing. So I just do start strategy. Oh, sorry, it is not showing here. So strategy, it shows me that. Now, after strategy, the type, what was that? If you don't remember, just do control space. It's going to show what should be inside this specification. Rolling update. Inside that, maximum search. How much is that you want? And maximum unavailable. What is that? I'll tell you in a minute. So now in no minute I was able to add the specification which you wanted. So that was a cool one, right? And you specifically mention what's the type. If you don't mention it, it's going to be by default, sorry, rolling update. So easily you can have that kind of a configuration there. Now, when you mention a rolling update, there are some specific configuration which comes into uh, place. First is the max search. So if you just look into the details, right, it's going to explain you the complete picture of it. The maximum number of pods that can be scheduled above the desired number of pods. Why do you need this? Remember, when we mention the maximum number of pods which we need to have is only one, and when you have mentioned maximum search as one, what it basically does is it creates few additional more pods than the desired state. Why? So that it can create the new one and the old one can get terminated for a short time. A spike, you're going to see a slightly more than the desired number of pods. This is only to make sure you don't have any downtime. So there's an example here. Desired number of, the value can be absolute, where you mention number one, or percentage of it. So it cannot be zero if maximum unavailable is zero. The absolute number is calculated from the percentage. Default is 25%. For example, when you set to 30%, the new replica set can be scaled up to immediately when the rolling update starts, such that the total and the old does not exceed 130%. So it's going to 130% when you do it. So this is all to make sure zero downtime you're going to achieve. Now, once the old pods are killed, the new replica, sorry, if I just scroll down, once the old pods are killed, the replica set will be scaled further, ensuring that the total number of pods running at any point of time does not exceed more than 130%. Uh, that's on the maximum search. This example is a very cool example. And if I go to maximum unavailability, so here the maximum number of pods that are unavailable during the update. So when you are updating, so how many can go down you are mentioning. So these two configuration is going to help you to achieve something which is like zero downtime. So basically default is going to be 25%. So you will never see a downtime. Yesterday, that was a reason when I was changing from version 1, 2.1 to 3.0, you never saw any downtime. So this was all because of these two parameters, folks. Max search, maximum unavailable stuff. So this is a very, very important thing. And similarly, you have few other specifications which you can look into whenever you have some time. Just mouse over and look into it. For example, container, if you just mention it, it's going to show the complete details of it. one important thing which I felt which is important, at least from the exam perspective, is image pull policy. Image pull policy. So this is when to pull the image. So when to pull the image, it's going to do it. So for that, the complete picture can be seen here. If you just click on that link, if you just mouse over on the image policy, it shows image pull policy. The possible options are always, never, if not present. If the image is not present, pull it. One of the one of one of always is okay. So if you have used latest tag, then how do I read this? One of always, never. Default is default to always if you have used a tag which is latest. If you have used a specific tag like 1.0, 2.0, something like that, then the default value is equal to if not present. So this is an important stuff. This could be sometimes important. So now if you're trying to change, trying to delete a deployment pod, when it comes up, right, new, and assume you have changed the image, whether it's going to reflect or not is going to be controlled by this thing. So if I just mention a small scenario here, I can show you a demonstration. First, let me explain it. So assume you have the container image version is 1.0. This is your this thing. Now you have one pod. You have a GKE cluster. You have a deployment, and in that you have one pod running. One pod running with version 1.0. All good, running fine. Accidentally, the pod gets deleted. And assume the setup is if not present. This is the current value. Now, accidentally the pod gets crashed. Now, when it comes back, right? When it comes back, um, when it comes back, it's not going to pull it. It's not going to pull it again from the container registry. So it just goes, the pod comes up automatically. It just uses 1.0 and does it. It does not go to the registry and pull it. It's going to have a cache and it's going to pull it from there. Now, this is going to be really helpful when you want something to be quickly come up, basically. Now, what if somebody who's just learning container concept, when they had a new version to be created, they modified all the code, but they tagged it with version 1.0 only. New code, mistake. New code, but tagged as version 1.0. So in your container registry, the older one is going to become untagged. So because you're overriding, right, it becomes untagged, and the new one will become version 1.0. Now, it will not reflect in your deployment. Whatever you do, it's not going to reflect the new change. Even if you go and delete your, if you delete your parts, individual parts, it's not going to come up. So because you have mentioned if not present, only if the image is not present, it's going to pull it up. So uh, in that case, if you are going to use, sometimes some people use latest. They use latest. So for the image to pull up, whenever you do a delete of your pod and you want that to the new changes to pick up. So if you have tagged it as all latest, the images, the image pull policy is always this one, meaning it's going to pull the new change from your registry and it's going to reflect it. So two options. If you are using tagging like this is the option which is going to be the default image pull policy is going to be this. If you are using latest tag, if you are using something like using some versions which something like this, so the policy is going to be basically if not present, only pull it. So this is an important thing, folks. Uh, and we know as per Kubernetes official documentation itself, avoid this is what they mention. So prefer to use if not present most of the time. So caching also it's going to help. So now if you say then how will it reflect the newer version, then you create a new version itself. So don't create an image with an existing version, then you'll have issues not reflecting the changes. You want to create a new one, create a new one, don't retag it with the same version. That's the best option. Is there a question?
No, that's what I have the same question, and you explained that. Thank you, Mahesh.
Yeah. So always keep doing this, keep creating multiple versions. Now, implementation tip, I also am doing currently one implementation. There are where people, the developers are really good with creating these Dockers, all those things. But what happens is if you keep on doing like this, if you keep on doing like this, the versions keeps on increasing it, meaning you have multiple versions in your container registry. Now, definitely when you are currently, if your latest version is say for example 10.1, 100% sure you are never going to use 1 dot version, 2 dot version. Now if you just leave it in your container registry, right, it's going to incur storage cost. Now this is an implementation tip. So what you should do is basically have some kind of a script. There's no setup which Google provides you where you can automatically delete old container images. So if you don't want, you have to write some gcloud command or some other script which goes and cleans up every images which is older than container images which is older than 30 days or something. So this is something which you need to make sure you do it regularly. If I just go to my, if I go to my container registry, it's, I have seen it. So hundreds of images are there in the current implementation. So I've already asked the team to clean it up. They are yet to do that. So the implementation which I'm, because I'm not the complete owner of that project, I can only give recommendations there. So I've asked them to do it. So if I just keep on creating versions, now already if you see, we're not we're not even using version 1.0, 2.0 we are not using. So just delete it. So at least you can release some space. So if you release space, you are going to incur less cost because this is going to be stored in Google Cloud Storage. This is an implementation tip. Let me just put it in the tip. When you are implementing it, add this line. If you're going to use, basically container registry as your GCR as your registry, prefer to delete it. So have a have a have a custom script, and Google does not have anything currently out of the box. So have a script to delete older images, older Docker images, uh, older images from GCR. So Docker Peon images are there deletes the stale images? I think you told us before. Sorry, so many questions. Can we do this via Terraform as well? Via Terraform, no.
So there is a
Terra,
Docker prune command is there we are using currently, and we have made as one of the pipeline which is running after which is checking any pipeline, any image which is older than 30 days and not in use. So there is
so it's a
there
custom.
are various ways. Yeah,
It's a custom script, so it's not there out of the box which you have.
not by
So
Google.
yeah, not by Google. So the reason is you have to put this. Now as an architect you are saying X number of days for implementing this. So that's the thing. So Vijay Kumar, I don't think so. Okay, so Terraform is basically the infrastructure provisioning. To run the script, if you need a virtual machine or if you need something like a cloud build, then you can configure those things via Terraform. So but what is going to be there inside the script, you have to write it, and that has to be coming from a source. So Terraform is for infrastructure provisioning. Once it is provisioned, you will use something like a cloud build or Jenkins to provision your code, basically.
Yeah, and it is advisable not to use any command via Terraform, because there's a provisioner way. So if you want to execute any commands, you should go with the Ansible to do that. That's a housekeeping job, because you should be able to retain those state earlier. So Terraform is mainly for those,
Only for
not
the
for
infra.
running command.
Only for the infra. It's the
Yeah.
infra. So only for the infra usually. So that's something on the tip, folks. So there are lots of such things. So use this editor, you get important stuffs. And I had seen this image pull policy, max search kind of questions. So I thought, let me at least show you that. And the strategy rolling update is a default one. So when we do our module 7, there we are going to see the different types of deployment. Rolling update is something which is going to be there. Canary update, canary deployment, blue-green deployment. So this is one of the possible options which you get, and this is default in Kubernetes. So that was a small tip which I thought of sharing. Now let's go to the next component, which we were just doing it for understanding how Kubernetes works, all those things. So we saw deployment. So thanks Anil for putting it. So we have seen how deployment works, the various components in it, all those things. The next part is services. So if you just create a deployment, you can access those components which is running inside the cluster by directly going into the pod. You don't need a service if you are not going to access it outside or within different services. But if you were to use that workload or the microservice which you have deployed, you have to expose it as a service, then you can consume it. And there are different, and if you see deployment, inside deployment, what you have, replica set, and I got this image from the official official Kubernetes documentation. Then you have pods, and each pods have some labels. So this is a nice diagram, right? So deployment, inside that you have replica set, pods, all those things. Now for a minute, just think only you have this. Now if there is a service running, if there's a service running, how will I access it, folks? For a minute, ignore you don't have these things. Just think only you have this. I have a hello world application, a microservice which I have deployed as 3 replicas. It is running there. Now how can you go and access it? I wanted to access those microservice. When I run curl a specific IP, it should show. How would you access it? Any thoughts? Default, if you have not done anything, Anil is going to come, that Anil B, that option is going to come. So if I just repeat the question one more time, so you have just created a deployment and you don't have any service, but I still want to access my content in my pod, meaning I'm going to use this IP, folks. No service, but I can still access my microservice, the content what is running, by just going into knowing the details of my pod. Just go curl 10.10.1 10.1. If I do that, it's going to show me welcome to containerization. Simple. So I don't need a service if it's very simple, if I'm going to rely on this pod. But what's the problem with just relying on this uh, pod IP? Pod is going to have an IP address. That's the important thing which we have learned. But what's the problem if you just rely on this pod on this IP? The problem is going to be, if the pod gets deleted, it's going to have a new IP address. Now we have to change the IP address. So instead of doing relying on the individual pod, you're going to get a kind of, I would say, a proxy where you can create a service, where this is going to be your kind of a gateway where people are going to access your service and they don't need to worry about the pod IPs. So that is going to be updated in the internal DNS, and it's going to keep you, if you want to access your service, you access with this one, 1.1.1.1, this IP, and access it. And this can be a cluster IP, which is a default, or it could be a node port, which is a superset of your cluster IP, or it could be a load balancer, a superset of node port. So no load balancer is what we were doing most of the time throughout our demo last couple of classes. Now, first, what I will do is I will go and delete my service. Delete my service to understand this concept. I'm just going to delete my service, only have a deployment, and show you how I can access my service via the IP address, and show you the importance what is going to happen when you delete a pod. Because it is part of deployment, it's going to come up, but when it comes up, the pod comes up, it's going to have a new IP range. So it's going to be difficult in my applications to always update my pod IP. So rather than that, create a service. So that's what I wanted to highlight here. Let me just show you that concept. Just go to my service. So if I just do kubectl get svc, the service, there's going to be one service running, the no load balancer, the one which we started yesterday. So I'm just going to copy that, and I'm just going to delete it. Delete svc, the name of the service. So this deployment does not have any service itself, but I can still access it. How? With the help of my pod IP. So let me show you how it works. This is just to make you understand, folks. That's the only thing. So let me just wait for it to get deleted. Once it gets deleted, I can have one more tab so that I can easily switch between the tabs. So by the time that comes, kubectl get svc. So this is the default service which is going to be there. This is your cluster IP. What is cluster IP? I'll explain you in next few minutes. So we have not come to services yet. So if I do deploy, I have a deployment. If you want to know the pod, all those details, what you can do is basically, I want to know the replica set, I want to know the pod, complete details, you do it, you are going to get it. You're going to get it. So now I wanted to see my app which I have deployed. Welcome to containerization. How do I access it? So basically, if you can log into this pod, you can access it. So let's try to log into this pod. So execute. So I can just do something like this interactively, and I can go in a bash mode. Okay, so this is okay. I have to do something like this because it is a Alpine image. Bash mode is not there. SH mode. So let me go in SH mode. Now you see from dollar I am in hash, meaning now I can just do curl localhost. Curl is not found because the OS is Alpine. This is Alpine. This is what we created to reduce the image size. You can add, you can install curl if you want by just doing apk curl. It's like how you do apt update package manager. You can do the same thing in Alpine also like this. Now, if I run this, it's going to show me. It's going to show me. Now you want to see the IP address of your pod. You can also get to know it's this one. This is my IP address. So meaning with this IP address, I can also call it. It works. So anything, any pod running in the same cluster, if I just give this IP address, I should be able to call it. Basically, that is the indication. I don't need a service. I don't need a service. So how do you know the IP address? One way, you just log in and get it. Other way which you can do is, if you go to your deployment, no, I may not get it. Okay, you will not get that details if you go here. Okay, let me just see if I can get it. I may think you may not get it. You have to go and get it because For exposing it, there is no endpoints currently. So you don't have any service. So the only way which you can get is go to the pod, get it. Go to the pod and get it. Now, if I just come out of this pod, if I try one more time, SH, now you see some message, folks. This is very important. I have seen many articles, even my videos gets usually outdated. The content at which Kubernetes, Google is doing, so content gets easily deprecated. Please look for some deprecated messages. It's going to help you out. So what it is saying is, yes, it has logged into the pod, but this command is going to get deprecated soon in the future version. So what they are saying is, don't execute this, rather run a command something like this. You put hyphen hyphen and do it, meaning exit. Don't do interactively. You don't need to have anything interactively. Remove this, the pod, put hyphen hyphen. What is the command which you are going to run in that? You run it here, IP space A. No message of deprecation. Now you want to see anything else? What you run in that machine? Something like curl the IP address. This is what the message is indicating. So it is showing you that stuff. So okay, this is basically how you can just, if the pod is there, you just access it. Now if I want to access it from some pod, can I use this IP? Definitely, because it is in one cluster only, right? You should be definitely able to access the pod from another pod. So this deployment also has one pod. I have a standalone pod. I can use this pod, connect to this pod and access it. Let me just show you how I do it. So without service is what I'm trying to show you first. So for that, I'll just get the pod IP from this deployment. Now what I will do is there any service? Except the default service, nothing is there. Now what I will do is get pod. So this is the pod which I'm going to use. Now what I'm going to do is kubectl execute this pod. Now I'm going to use curl, and this is from the different pod. So if I just do this, I'm accessing a different service altogether. What is this stuff? What was this pod all about? Curl. Okay, curl is not there. Okay, curl is not there in this pod. So first I have to install it. So I can do apk add curl. Installed. Now welcome to containerization. So even from a different pod I can access it. So this is all good. This is all good. Without a service I can leave is what I get. But what if you delete the pod? So what happens if you delete the pod? So let's try to delete it. Let's try to delete it. So for that, I'm just going to leave the screen as is. Use this command watch kubectl get pod. So let that run. So the current pod is running. The name is KP, ending with KP. So hope I get a new cloud shell. Hope I can get it. 4 is what I have basically 4 pods. Easily do this. So okay, let me do this, folks. I can do it. So if I don't have this alternative, so I'm just going to delete a pod which is part of the deployment and show you what is going to happen. So this pod, the whole why I'm showing you this, when I delete a pod and a new pod is going to come up, we know because it's self-healing capability is there. But what's going to happen to your IP address? The IP address is going to be totally new. So let me try deleting it. I'm deleting it in the UI. So you should see it is terminating and a new pod is coming up, which is CVV is the name of it. So the old one goes off. Now, if you are connecting from this hello pod with the old IP, you will definitely get an error. Let's try to see what is going to happen once the pod is fully up. So yes, it is running, and the other one is terminate. So now the command which ran last time, let's see what is going to happen. It's not giving response, giving me that welcome to containerization, because the IP address has changed now. The IP address has changed and you're not able to access it. So this is where the value of service comes into picture. So it does not connect. After some time it's going to time out and show me I cannot connect. That's it. Host is not reachable. Now why? Because you were relying basically on the IP address of the pod, and pod is mortal. Pod is like us. Humans die, so pods also die basically. So then if you want to know the actual IP, basically you have to again do the same stuff. So kubectl get, let me just keep this. So kubectl get get pods. You want to see the IP of the new machine, the new pod, sorry. You run this command, IP space A. So what's the IP? It is 10.32.1.4. What was the one which was previously 3? So definitely you are not able to see it because the IP keeps changing. When a new pod comes, the IP keeps changing. So if I put the updated one, I get a response. Welcome to containerization. So this is without a service. Now, if I don't want to play around with this IP address, all those things, better create a service. And the default service which you get is cluster IP. So let's try to create a cluster IP and see how this can be completely resolved with just playing with the help of that service, which is of type cluster IP. That's the default one, which is going to be basically an internal IP address which can be accessed within the cluster. But if you want to access it outside the cluster, you have options like node port. What is that? I'll explain you. And if you want something much better, then you go with load balancer. If you want much better, you have an option called as Ingress, which we'll talk after we come back, maybe after the break. So we have some time for the break. So after sometimes we'll look into the fourth option called as Ingress. So first let's try to create a cluster IP. So how do I create a cluster IP? It's a service. It's a service, right? So we have our relative approach. We can just go and try it. For that, I'm going to open up my, till now here, is it clear? What we have explored was only deployment. With the deployment, without any service, how can you access it? I have shown you a very crude way. You have to rely heavily on your IP address of your pod. So this is the last time you're going to leverage the pod IP. Sorry, there was a small disconnect. So this was the only time we are going to use our pod IP address. Going forward, we'll never ever use our pod IP address. We are always going to access the pods via the service. So is this concept clear, folks? Without a service, how can you access it? If somebody asks you as a question, if it's more on something infrastructure related and Kubernetes related job role which you're getting, you can always access it via the pod IP. Sorry, pod IP address easily. Is this concept clear, folks? If it's not clear, looking into the service will not make it clear. So this is a lead to that concept. Is that concept clear, folks? With just the deployment, you have a pod. The pod is going to have an IP address. From the pod, I can access it with the pod IP. And if there's any other pod in the same cluster, I can also use the IP and access it. Yes, no, folks. Is this concept clear? Or was it confusing? Okay, so if the concept is clear, now we saw the drawback of this concept. IP keeps changing. I cannot assume it is an application, some other application which is going to call this. Every time I cannot go change this. It's going to become problematic, right? So instead of that, what I create is I create a service, and this service is the one which is going to expose it to the outside world or within the cluster itself, but you don't need to juggle around with your IP address. Just use the service name and you can call it. It becomes very simple. So it internally also uses something called as internal DNS. All those things comes into picture. So let's try to create a cluster IP, and I really don't know how to create it, but I believe the Cloud Shell editor is going to help me out to create a service. So let's create one. So open my Cloud Shell editor. I'll go to my source repo, which I kept yesterday, this one. So in that folder, I'm going to create a new file called as service-cluster IP, only for me to differentiate it. YAML. Done. Do control space. It's going to show me lots of options. What I am interested is in service. Kind of object is service. Now you give a name to your service. Hello. That's the name of my service, and by default it is always cluster IP. If you want, you can make it as load balancer. So I'm just going to keep it as cluster IP itself for now. And how it knows which pod it has to connect to, all those details. It's with this selector. So if I just go to my deployment, I would have mentioned, right, the label is hello. This is going to help me to connect my deployment, the pod, with my service. This is how that basically does, the pod selector or label selector, to be very specific. So that's how the connect happens. Now what it is saying is, I want a cluster IP running on port 300, and the container is going to be 8080. Let's just do that and give a try what's going to happen if I deploy this. So how do I deploy this, folks? Where I am currently. How do I deploy this? I have this service -cluster IP YAML file. How do I deploy it, folks? I have to apply this. So how do I do this? Yeah, no, you have already created it. So you have already created it. So never ever use kubectl create. Never ever use this. So if you use this create, right, it's going to be again imperative. And so always use apply. This is going to be the best way for declarative stuff. So use this way. It's going to create you a cluster IP. So which is an internal IP address, the first and the basic thing. So to make sure whether it gets created or not, I'm going to put a watch command to see what's going to happen. SVC. Currently nothing is there. So I'm just going to create. I have this deployment done. So a new cluster IP came. So this is my cluster IP. Now going forward, how do you get the YAML file? Okay, I'll show you that. So you just go to your editor. So you need to create this kind of a YAML file. How do you do it? Basically, you use your editor, give any name, cluster IP demo YAML, do control space. It's going to give you the various templates. The template which I'm going to use is Kubernetes service. So give a name to your service, something like hello 2 or whatever it is. Then you have it. That's it. So I'm just basically using the template which is already there, Anil Kumar. So I hope it's clear. You may use some other tool, but because this is built in, I thought I leverage Cloud Shell editor stuff. So once you have the YAML, you can just do kubectl apply. That's it. Is that clear, Anil Kumar? Uh, is that clear? Not clear still? Control space. Control space. Space. Developers usually would have used it when you want auto suggestions. So usually they use that. So they kept the same thing. Or when you start typing itself, it's going to show you the suggestion there. So let me just delete this. I just need these things only. Now going back, I have my cluster IP. So this is a internal IP. When we do networking, we'll look into this one more time, how this IPs comes. So at a later point of time, you'll look into those IPs, but these are internal IPs. Now there's no external IP, and the port is 3000. So how do I access my welcome to containerization this thing? Basically, what you do is you go to any pod, access it with this name or access it with this IP address. You should be able to access it on port 300. So let me try to show you that. So for that, kubectl get, and I have to be in one pod so that then only I can access it. So I will be in hello pod. Okay, I'll be in hello pod. So I'll do something like this: kubectl execute --curl hello. What was that service name? Hello service. Hello service, and that service is via 300 port. If I just do this, I get that. Welcome to containerization. That's it. Now, or you use the IP, your choice, the IP of the cluster IP, which is an internal IP address. It works. Now let's go and delete the pod. Let's go and delete the pod and see what's going to happen. So what's going to happen? So I'll keep this. The IP is a little difficult to remember, so but I'll just keep this. So we are going to use this. Okay. Now what I'm going to do is I'll go to my pod, delete the pod. If we delete it, new pod comes, self-healing capability, but the new pod is going to have a new IP address, but it's not going to impact my the way I'm going to access it, because I've created a service which is cluster IP. So let me just show you. So go to my pod. I can just run this command behind the scene so that you know it is getting really deleted. I'm not cooking anything. So pod. So it is ending with CVV. Let's say bye-bye to this. Terminating, the new one is coming up. It is 8x, meaning definitely the IP address of this pod is going to be new. Now, if I just go ahead and access it, still it's going to work. No difference for me. So that's the most important thing of your cluster IP, folks. Is this concept clear? And everything is via internal IP, so I can access my service only within the pod. I cannot access it outside. For accessing outside, we have few options. I'll come to that. But is this cluster IP clear? Which is the basic version which you get, and the default one, Is this concept clear, folks? I would usually ask your confirmation there. So if that's clear, good. Now, what we will do is, what is the next option which you have after cluster IP? So we have one cluster IP for this, working fine, good. Now, but I want to access this outside. I cannot always come and do this kind of a stuff. I want to access it in my web. You cannot access this because it's internal. So then the option which you get is something called as node port, which is a superset of your cluster IP. So meaning when you create a node port, it's going to have a cluster IP and it's also going to have a node port. What is node port? Node here indicates basically your virtual machines which you have created. So where all your stuffs gets executed, right? So when you create a 3-node Kubernetes cluster, 3 virtual machines are going to be there. So basically this is the port of your virtual machine. Let me just show you a nice diagram here so that you are going to get it. So cluster IP is going to be something like this, folks. Basically use a service name dot namespace dot svc dot cluster dot local. This is one way. This is your internal DNS. Or you can just use your, if you have no namespaces, you just use namespace. If you keep it in very simple terms, what is a namespace? You have a cluster. By default, you are going to have a namespace called as default. You can have n number of namespaces. Namespaces are basically, in very simple terms, if you treat your apartment, if you're living in an apartment, as a Kubernetes cluster, each floor you can treat as your namespace. So, and each house you can treat as a something like a pod, and people inside the pod you can treat it as container. So that's a small analogy which you can do. You can have n number of namespaces. How this namespace comes into picture, basically this is, if you were to give access to a specific group, you create namespace. So you create one namespace for marketing, one namespace for payroll, one namespace for R&D, all those things. So one powerful cluster, because cluster management is going to become difficult. So people what usually do is, in an organization they create a very powerful cluster and they create multiple namespaces and give access to a specific namespace. And you can also come to know which namespace is being consumed heavily or used using an option called as GKE metering, which we saw at a high level in our last Sunday's class, if I'm not wrong. So you can use this. If you don't have any namespace, just use a service name, it's going to come up. If you are calling it from another namespace but from the same cluster, you can have this complete name. Let me just try and show you this, then we'll know. So if I just access it this way, curl default dot svc dot local. This is going to be the complete name, namespace default cluster. Now, why you need to mention this kind of a local DNS stuff? If you have multiple microservice, one microservice calling another microservice, at that time, if you give this complete URL like this, it's going to call. So at the end, everything is going to be microservice based architecture only. So using this kind of internal DNS is going to help you out. I get it. So maybe if I am calling, if this pod is in some other namespace, not default namespace, but in some other namespace, then you can call this with a complete URL like this. It's going to resolve it for you. So this is your cluster IP. Now, what is node IP? It's going to be, and again, this is a screenshot which I got it from Medium post, which was created by a Googler called as Sandeep. That Googler is really good with the Kubernetes concepts. If you just search for Kubernetes Google Cloud, few of the videos which you get is from that person, Sandeep. I don't remember his second name, but those videos are really good. This is your node port. How it works? Traffic goes via your virtual machines. Those are your nodes which you have created for your Kubernetes. So it goes via that. A cluster IP, it's going to be there. There's going to be, because node port is always a superset of your cluster IP. So when you create a node port, you are going to have a node port plus a cluster IP. So traffic goes to your VMs high port, usually between 30,000 to 38,000 ports. From there, it goes to your cluster IP. From the cluster IP, it's going to hit your pod. So this is the propagation, how the traffic propagates. Let me create a node port and show you basically. So now, since your VMs are already exposed, it's going to have an internal IP address. So accessing it is going to make us expose it to the outside world, basically. So the cluster IP will not allow us to access it from the outside world. With node port, I can access it. So after we understand node port, we'll come to our load balancer. So if I just go to my this thing, again, I'm going to create a new service, I can create n number of services. So I'm going to open up my this thing editor. Now let's create something called as service hyphen node port. Service hyphen node port dot YAML. The extension is very, very important. Otherwise, the auto completion will not work. Then control space bar. You're going to get that option service. and I'm going to mention the service as now hello service node port, so that I differentiate it. That's my node port, but my namespace, the app selector, what you have mentioned in your deployment was hello. I'm just going to keep it like that only. I'm just going to keep it like that. Now this is what? Again, cluster IP. I don't want cluster IP. Just change this to node port. So node port, this is the type of service which I'm going to deploy now. Node port, the name of the node port is this one. The selector is going to be hello itself, because that's what we have mentioned in our deployment.yaml. Same port, this thing. Now what is this going to happen is what is you will be curious to know. Let's try to deploy this. No worries, Vijay. Take. So so what you're going to do is, the only change which you did from the previous to here is gave a new name so that you can differentiate it, and you change the type from cluster IP to node port. That's the only change, folks. Now let me go ahead and deploy it. Now you know how to deploy it. So let me just run this in a watch mode. You're going to see a new entry. You're going to see a new entry, and you will compare a node port with cluster IP. So let me just go and deploy this. Hope I'm in the right folder. Yes. kubectl apply minus service. Done. Done. If I just go, you see a new entry, folks. The type is node port. Awesome. Now we saw in our slide, node port is a superset of cluster IP, meaning when you create a node port, you are going to always have cluster IP there. So what is the cluster IP? This is the cluster IP, and the port via which you can access it is 3000. We know how to access it, but compared to the previous service and the new service, what you see is a high port, HIGH, high port. Usually high ports are in the range of 30,000 to 38,000. So it will allocate randomly one port to you, meaning if you have your nodes from the node, you open up this port, you should be able to access it from any node which is part of your Kubernetes cluster. You should be able to access it. And similarly, if you were to access it via this cluster IP, even that is possible. First, let me show with the cluster IP, then go to my virtual machines, connect or use this port and see how I can access it from the external world. So first, cluster IP, because node port is also Control C. So let me just do this. So if I just change this, I get my response. Welcome to containerization. So there's a way I can silent it. Minus O if I'm not wrong. No, what was that command, folks? Minus S. I don't want those message. Yeah, this is a better one. So this is a better one. So it shows welcome to containerization. Good. Now if I use the other one, it's also going to show me that stuff. So I have two cluster IPs. I can access it. This is okay, but it's still internal. But how do I access it from the outside world? Basically, what you do is, if I just refresh this. So you go to your virtual machine. Go to your virtual machine. So you have these virtual machines with external IP address, right? So we can easily access this IP, any of the IPs which you have. So put that, go to your node port, which is mentioned there, 3232371. Just use this and you should be able to access it. Let me just try to show you that. And if it's not working, then the only reason why it's not working is because the port is not open. Firewall rule is not open. That is the basic stuff. So it's not opening up because the port is blocked. So let me just quickly do it. Again, a jump to networking, but let me just do it quickly. Firewall rule which we are opening. If I just go to my networking, open up that specific port. So open up that specific port. So allow node port. What is that port? I'm just going to leave all the default stuffs. More on networking in our networking class, the firewall networking class. I'm just going to allow that port, folks, nothing else. TCP port, which is high port, 30,000 to 38,000 usually. So just allow it. Done. The port is going to be allowed. Now if I go and refresh it, it works. You can also try it. So this is the first IP. Now you want to see the second IP, just go to your virtual machine. You are going to get the IPs of your node. So that's the IP. The second IP is that also works. You can give a try. Any port, any node, any node IP is going to work for us. So the last one, 62. This is the last one. 32371. It works. So this is your node port. Now you have got an exposure to the outside world, to an outside world. That's what diagram depicts. From the virtual machine, it hits your cluster IP. From the cluster IP, it's going to go to your this thing. Is this part clear, folks, about the node port, how the node port works? Node port works, how you get access to the external world. Is that clear, folks, or any questions on this part? So there's no, okay, clear. Thanks for mentioning that. So now this is good. Now when this cannot work, the node
My
port is,
my
yeah,
my one small question.
yeah.
Whenever you're executing, you definitely need to mention the execute pod also, because on that pod we have written the command. That is the reason you are executing the pod, and then the other command.
Did not get your question. So which command you are saying? The
Okay, when you,
execute is this one,
yeah,
this
yeah,
one.
that hello
You
pod,
need to
hello
mention the
pod.
pod. Yeah, you need to mention the pod name.
Okay,
Yeah. Pod name. Then what is the command you want to run in the pod? Basically, it's at the end.
but
Nothing but a lightweight container. Yeah.
if I have multiple pods,
Hmm.
then
You have to
if for
mention the
example
pod.
one,
You have to mention the
okay,
pod name. You have to mention. You get the pod name like this. You get the pod name. You can have n, no problem. What pod you want to log in, just use this command.
okay, because all these pods comes under that same cluster node, so that is cluster IP or port node, so it will work for any other pod as well, correct?
Uh, it will work for any other pod. Did not. So cluster IP, right? It's if you see here. So cluster IP, so you are now not directly accessing the pod, you are accessing it via the service. So the service is going to keep all the DNS, all the IPs here. So there's going to be an internal DNS it's going to create. So updating it, if a pod gets deleted, a new pod comes, its IP is going to be registered here. There's going to be an discovery which is going to happen. So you don't need to worry about what is a pod IP, but you just need to be knowing what is the service name or the cluster IP service, sorry, the service name or its cluster IP. So if you know that, that should be good enough for you to access those workload, Kumar. Clear? Not clear?
Yeah. Just to understand, for example, if it is a google.com, for example, okay, so my application is google.com, right? Correct. So, and I use the the new one, which is node port.
We'll come to that. Oh, hold on to that. I'll come to that. So if you're going to go to that level, there's a different option. I'll show that. How it works, I'll show that. Just keep your question, I'll answer it. Okay, so this is the node port which we just saw. This is going to be a good choice when I want to expose it. But the problem comes is when you are going to deploy something in production, you not have nodes with external IP address, because what in production you will going to create, which we have also documented in our implementation, is always create a private Kubernetes cluster. Private Kubernetes cluster will never have an external IP address. So if it does not have an external IP address, you cannot access it like this, right? So then you have again a problem. So you again have a problem because if I were to access it from the outside world, I should have an external IP address. So node port will not be a good fit there. So that is where you will do usually a load balancer. So what's going to do with the load balancer is the load balancer is going to have an external IP address. Even though your virtual machines, your nodes will not going to have an IP address, your load balancer is going to have a new IP address, which is the service which you're going to create. Then it's going to hit your cluster IP. Then it's going to do it. So this looks better, right? So let's go and try it. We have been trying this node port for from last week only. So node port is your superset of your load balancer is the superset of your node port, meaning you will have a load balancer, you will have a node port, you will also have a cluster IP. All three is going to be there when you create a load balancer. Let's just go and try to create one. So if I just go to my service, I have a cluster IP, I have a node port. Now let me create a load balancer. Okay, so again, leverage the this thing, Cloud Shell editor. So I'm just going to call this as service hyphen load balancer dot YAML. So control space bar. Now I'll call this as hello hyphen load balancer, just to differentiate it. Load balancer, and the type is load balancer. App name, actually it should have got changed, but it did not change it. Hello. That's what we have mentioned in our deployment. Same thing, folks. The only change was the name and the type was changed to load balancer. Nothing else. Let's go and try to do it. So again, I'll put it in a watch mode. We will have a new entry. So let me just do that. Apply kubectl apply -f service load balancer created. Now you have a new entry, load balancer. So that is also going to have a cluster IP because that's the base, and you are also having a high port, which is for your node port. But what you are getting new one is a external IP address. This is a new thing in this option. So let me just show you. Once it comes up, it's going to create behind the scene a network load balancer behind the scene. So if you want to see what's happening, I can just quickly go and show you under networking. So networking, we'll talk more about this load balancing. So you see this is the load balancer getting created, and if I go click this is my IP address. This is my IP address basically. Yes, it is running. It is running. So let me just Control C. I have a new node port. A new load balancer. This is my external IP address. Now I have an external IP address with which I can easily access it. So go. That's it. It works. So it works. Now I don't need to worry about the node port, all those things. But if you still want to access via node port, it's the same procedure. Open up this port. From any of those node port IPs, you should be able to access it. Or you want to access it via cluster IP, you can also use this service or this IP address. So 3 different ways. Now let me just show you the last option here. So if I just send, it works. It works easily. Simple. So the whole reason of showing this part is you have cluster IP, which is going to be default. And when you create a node port, you will still have cluster IP and node port. When you create no load balancer, you will have cluster IP. You will also have a node port and you will have an external IP address. So it's a superset, basically, the load balancer. So is this part clear? Folks, now if you want to see where the services keeps all the details about the load about my node IP, all those things, if you want to know that details, so you go to a service, any of the service which you have, any of the service. If I go here, the first one, which is cluster IP, if you go to the bottom, you should see this one. What is this, folks? Can anybody tell me? So I'm in cluster IP. I'm in services, not in workload, services. So when I go to my cluster IP, when I click, this is my cluster IP address. When I click on this, go down, I look at my pod. My pod, this is the endpoint. So this is my pod IP address. So the discovery is going to happen via this. So if you want to verify whether this is really your pod IP, just run this command. Just run this command. I have to scroll down. So do kubectl get pods or pod, whatever it is. Now let's get the IP address of this pod ending with 8x. What is the IP address? 10.32.1.5. This entry is going to be updated in the service everywhere. Okay, and there's one more command which Anil gave, so that's also a handy option. You can do this also. So this is one way, or if you don't want that way, you use O-wide. So if you use this, it's going to show you the IP address of your pod. This is another way. So thanks, Anil Kumar. So this is another way where you can get the IP address of your pod and in which node also it is running, you'll come to know. So it's a 3-node Kubernetes cluster. In which particular node my pod is deployed, you will also get that details with this O-wide flag. So similarly, if you look into any service, you will have the details of the pod captured. So if you go to no load balancer, that service discovery is going to happen via this. Now, if your pod gets deleted, a new entry is going to get updated. So that way the service is going to keep track of those things and you don't need to worry and you just access it via the service name. That's it. Okay. So is this part clear, folks, about the load balancer, node port, and cluster IP, how it works? How it works. So how it works. Now, load balancer can also have a problem. What is that problem? We'll try to understand it once we come back from the break. So I'll try to show you what could be the problem will happen when you just use load balancer. Then the solution for that is going to be something called as Ingress. How Ingress works. We'll see two things and then move on to the next topic. So if there's any question, think about it. If you have any questions, come back after 10 minutes. If something is not clear with the types of services which we have discussed, cluster IP, node port, load balancer, if there's anything, we'll answer it. If there's nothing, we'll go to the next part called as Ingress. Why do you need Ingress and what is the drawback of load balancer? We'll see it and then proceed further, folks. So take a break and come back.
This conference will now be recorded.
Now, before the break, we saw the three types of services available. There's one more thing called as external name. To be very frank, I've never explored that external name option. So as per the documentation, cluster IP, node port, load balancer, and external name is there. You can explore the external name. I've never tried an option to explore that part. So at least in GCP, I have not used that very extensively. So what is going to be used in GCP, I have shared it with you. Last demo which we did was on load balancer. Now, load balancer is going to have some constraints also. What is that constraint? Let me just show you by doing a small demonstration. Then you will really appreciate, okay, what is the value of Ingress, the next option which you are going to see. And Ingress is not a service, basically. It's not a service, basically. It is, I would say, it is a kind of a L7 load balancer which you get. Basically, in every cloud provider, you get different types of Ingress. You get Ingress from Nginx, you get different types of Ingress. In GCP, the Ingress is always going to be a global uh, L7 global load balancer. So what is the why you should go with Ingress? First, let me explain you by doing a small demonstration. So all this time we are been deploying only one kind of workload, the welcome to containerization. That is the thing which we created. Now let me try to deploy another workload, which is an Nginx. Nginx is basically a web server which serves static content, similar to your IIS server and Apache web server if you have used it. So let's try to deploy one more, have a new deployment, open my this thing, create a new deployment. So I'll call this as deployment hyphen nginx.yaml, where I'm going to use something like engine X. This is my deployment name, engine X. Now what I'm going to do is I'm not going to use this one. I'm not going to use my GCR for anything here. So I'm just going to mention engine X. So if I don't mention anything, so if you see here, the registry is Google Container Registry. You have some different registry here. So if you don't mention anything, just mention the image, it's going to pull from Docker. It's going to pull from Docker, basically. Now this listens usually on port 80. Usual port is port 80. So what I have done, I have created a new deployment with the templating option which I get in the editor. Now I want to deploy a new one, and it's the image is going to be Nginx, a web server. Let's go ahead and deploy it. Let's go and try to deploy it, and we should have a new entry. That's it. We should have a new deployment, which is not our hello world kind of a stuff, but something called as Nginx deployment. So let's try to deploy this. So kubectl apply -f deployment hyphen nginx. When I do this, a new deployment is going to come up. So want to see that, you can see it in this deploy deployments, everything is going to show. So Nginx deployment is done. So if you want to see the pods, what is happening? Okay, so I have one pod from my hello deployment, one standalone pod, the other one is Nginx. So in this Nginx pod, if you go and log in using this command kubectl execute or connect to this pod, I can run something like curl localhost. Why localhost? It is inside my pod. I'm going inside the pod. So if I do this, I get better use this one -s. So I get a different response, folks. It does not show me welcome to containerization because I'm having I'm trying to access my Nginx. So it's going to show welcome to Nginx, the home page, the default page of your Nginx. So this is one deployment which I have created. My requirement now is I have to expose this. I have to expose this to the outside world. What is the option which you would prefer, folks? I have a deployment. But I don't have that as a service. But I want it to be exposed to the outside world. What would be the option which you can prefer me? Cluster IP, no node port, or load balancer? Good, good. So Anil Kumar got it correctly. Basically, your load balancer, because you want to expose it to the outside world. This is what you want. So what we will do, we'll create new service. Simple. So let's create a new service. Again, leverage our Cloud Shell editor. So easy. Now it becomes so easy for us to create this. So I'll create it as service Nginx so that I don't confuse myself. Nginx.yaml control space bar Kubernetes service. The name of this thing is sorry, and 1 minute. Service Nginx. Then if you look into the label, what was the label you gave? Please look into the deployment. That only you need to give, otherwise it's not going to work. So the label is Nginx. Good. Now what I will do is, instead of cluster IP, I'm going to make it as load balancer. That's it. And my container listens on port 80. Now if you just leave it as 3000 here, you're going to access it, your load balancer colon 8000, which is going to forward it to the pod which is listening on 80. So let's just leave it as is and create it. So kubectl, or if cube is becoming a difficult, k, because I have a alias created, apply -f. Want to show you as much as possible options. Done. Service created. It's going to be a load balancer. So let me see whether it has created. A load balancer is created. Yes, IP address is pending. Let's wait for it. And it has a new high port. And now it is in 30,000 series. So we have seen 32, 31. So it can be up to 38,000. So these are usually called as high port again. So let's just wait for the external IP to come. Once it comes, we will access it on port 3000. If you don't want to access it on 3000, you want it on 80 port, we can also do that. I'll show you how we can do that. So we never touch that port number, we just left it as default. Now I have an IP address. So now if I access this port, $3,000, you'll not see the boring welcome to containerization, but you'll see an interesting page, welcome to Nginx. This is the default page of your Nginx. Now you say, I don't want to access it on 3000 port, Mahesh. What I can do? Simple. Go to your service. Go to your service. The port which you were mentioning here, change it to 80. Change it to 80 and run it. It's going to start working on it. So let's just apply that. Change. Done. Now, if you go back and verify it, whether it's updated or not, yes, it is updated. This is updated. Now, if I try to access on 3000 port, it's going to throw me, is it working? It should take, maybe it's cached. Is it cached or it's working? Or it's going to take time. Let me just wait for it to show up, or they made it wrong. One port, this is the port. So if I just mouse over, the port that will be exposed by this service, and the port which is going to be used by the container. So yeah, it's working. It is working. Try, folks. You should be able to see it. So what we did in this demo was we used a different container and we created a deployment and we created a service, basically. All good. Now, if any questions on this part, folks? What we did so far? We just created one more deployment and a service. It has a new IP address and we are able to access it. And you should be able to also access it. So
Mahesh, if you don't
now
mind.
if the requirement,
Yeah.
come again.
Yeah,
Sorry, I did not.
Mahesh, before you created the type equal to load balancer, you created one more NGINX, right? What is the difference between that NGINX and this NGINX? Can you show me, please?
Which engine? It's only one is a deployment, one is a service.
Yeah.
So let me just. Okay, the before and the previous one, it was only the same thing. The port was changed. On which port you want to listen? So I don't want to.
No, that I understand. Yeah, that is earlier you put 3000, then now it put 80, right? So before 3000, you created one more NGINX.
This is the deployment. This is deployment. You have to deploy it, right? So you need to have a deployment, and then you want to expose it. You need a service. So first create a deployment.
Okay, got you.
Which is going to use Nginx image. Yeah. So any other questions, folks? Any other questions? Now, if you see it in your UI, sort it. So now tomorrow you want something else. Assume you want something else to be deployed and you want to expose it the same way. You will do the same procedure. It becomes now simple. The only change which you are going to do basically is what is the kind of container image you are going to use. That is what you are going to mention and you are going to expose it. Now, what's the biggest drawback of this approach, folks? Any thoughts? With this load balancer approach, what do you think which is not good in this approach? External IP. How many external IP address will you create, basically? So you keep on, if you have 20 microservices, all want to expose to the outside world, then what will you do? 20 IP address, will you create it? It's going to be a little risky and more expensive also, right? Sorry, not little risky, sorry, it's more risky, so you are exposing it, so it's going to become expensive also and difficult to manage. So that's where every cloud provider provides something called as an ingress. It's like, I would say, like a filter or like a layer 7 load balancer, which helps you to avoid n number of external IP address, but you use a concept of load balancer, L7 load balancer. This behind the scene which creates is a network load balancer. We will create an ingress which is going to do this host and path rules, which we had seen in our MIG. The same thing is going to be applied here also. Ingress can be implemented in multiple fashions in Kubernetes. So if you just search, you'll get Nginx Ingress, and there are a few other options. Google, when it comes to Google Cloud Platform, the ingress is always implemented via load balancer, L7 load balancer. How does this work? You create a layer 7 load balancer. Now, if you want your welcome to containerization, you have something like that is one microservice. Your Nginx is one more microservice. Now, what you do basically, you create something called as node ports for these things and have this host and path rule mapping slash IP address slash. If you do, you want it to be served to welcome to containerization. If you put slash Nginx, it's going to be served from Nginx pods. So you can have different host and path rules where you will have one single IP but serving multiple microservices. So you play around basically with your domain or the context, the URL context there. So this is going to be much easy to manage, and one single IP address. That's going to make more sense instead of always having for every microservice which you're going to create. You're going to create and don't connect with your microservice and this service, folks. Microservice, when I mentioned, this is what is your actual business logic which is going inside your pod. So you are exposing it as a service. Cluster IP is going to be there or node port is going to be there. Then you are going to have one single IP address and access it basically. So you don't need to have multiple IP address to access your various services. That's what Ingress gives you. But one prerequisite, at least in GCP, I'm not sure about other cloud. When you create Ingress, you should have a node port first. So a node port service should be there. Then you configure your Ingress. So how do we configure it? Let's go ahead and try to do it. Again, using the help of our node port option. Sorry, again using our cluster IP. Sorry. Again using our cloud shell editor option, we'll try to create an Ingress. So we have cluster IP, we have node port, load balancer, all those things. So what I will now do is I'll just delete this load balance. Okay, I can keep it. I have no problem. So what I will do is, maybe I'm not sure how many IPs I may have. I may run short of IPs. Let me just see it, folks. 1 minute. The number of IPs I can allocate. How many IPs I have? There's a quota, how many IPs I can allocate. Just wanted to see that. So we talk about quotas. We have already talked about quota, I'm not wrong, in our MI. So even for of IPs in a specific region which you have, even that will have a limit. So these are the IPs which I have already created. 3 for our virtual machines. This one, this is a virtual machine. You see instance, VM instance. Okay, I cannot select it. Leave it. This is for the virtual machine. This is for the virtual machine, and this is for the virtual machine. And the middle two are basically your forwarding rules, basically created by your load balancer, network load balancer. And if you look, everything is basically regional and regional basically. So if you want to know the quota, how much is your quota, and everything is in Singapore itself we have created. If you want to see your quota, you can go to your IAM quotas. You'll be able to see the stuff. Are we close to the quota? So I guess 4 was the one, 4 or 8. Let me check what is the quota there. Okay, IP in use. So if I just click on this, so quota, this is for the VMs. This is for the VMs. There should be also an option here. Global, okay. Okay, 3 is what I have used. 3 virtual machines, 3 is used. This is for virtual machines. Global, have I used anything? Global 2, I have used. The 2, this is basically for load balancers. That's what it looks like. So it is 2 is already used. How many were we are having extra? So 5. Yeah, 5 is what we had, right? If I'm not wrong. So if I just go to my networking, external IP address, this did we 5, if I'm not wrong, 5. So it gives us an indication I have still quota. So this basically is for your load balancers, and the second quota in IP at in use IP address. This is for your virtual machines, where in Singapore 3 are used, basically current usage 3. So the orange color indicates I'm very close to my quota. Now if I create 2 more virtual machines, I'm all done, basically is what it indicates. So we have enough quota, we should be able to do it. So what I will do is first create a node port. So that's a prerequisite for your Ingress. So I'm going to create one more node port for Nginx service, Nginx, and then create a Ingress. How do I do that? Let me show you that. So cluster IP, deployment, load balancer, closing stuffs which I don't need it. So only what I need is the 2 deploy. Yeah, this should be good enough. So first let me create a node port, folks. New service node port nginx.yaml. So it's a service, then nginx, I'll call it as node port. Call it as node port, but my app in the deployment is called as node nginx only. So I'm just going to do that. Type I'll change it here. Type I'll change it to node port, and let me listen on port 80, or I'll just for a minute I'll just mention it as, so 9000. Let me make it as 9000. 9000, just to show you some difference. My container, my nginx runs on listens on port 80. So this is my node port configured. So let me just deploy this. Done. So if I just go, so I have 2 node port, one for my hello world, one for my nginx. So the node ports are there. This is 9000, this is 3000, all good. Now what I will do is I'll create a new new kind of object called as ingress. This is the, what is the kind of object? It's a service. The other one which we have seen, the kind of object is deployment, and we had seen also the kind of object is others are able to hear, folks. Anil Kumar is not able to hear me. Anything others able to hear me? Okay, Anil Kumar, just give a try by just dropping off and logging in. Try logging in back again. Drop. Okay, just check your connectivity, Anil. Maybe something went wrong. Check it out. So now what we'll do is we'll create a ingress. So again, new ingress. You can give any name, but the extension is important. YAML. Now I really don't know how to write this thing, but if I just do control space, I get an option for Kubernetes ingress. So let's leave the name as traffic router. Now this is the most important part, folks. So you have to have n number of paths here. So you need to have n number of paths. So copy, paste. So what I'll do is, if it is slash, I want it to be served from my node port, which is hello service port. This is the one which listens on port 300. 3000, sorry. Now, if I want to access /nginx batch 6, this is my path. If it is like this, it has to be served from another node port which I have just configured. This one. And what is the port? And this is a cool feature you see. The port it is listening on is 9000. This is how I create my host and path rules here. Is this part clear, folks? So what we have done, so node port is mandatory. Using the node port, you just need to have a node port, that's it. So if you create node port, you are going to also have cluster IP, but no external IP address required, no load balancer required, but you are creating an ingress. The type of the object is ingress, and I have created two host and path rules. / somebody access it, it's going to be served from our hello microservice or hello service basically. Then if it's /nginx -batch 6, it's going to serve from nginx stuff. Let's see whether it's going to get created or not. So this is the only configuration, but is this part clear? How we came to this? Basically with the help of our services, basically it is a node port service. So, and what was the port mentioned? We just mentioned it. That's it. So we just mentioned it. And since you have mentioned it as HTTP, basically you are going to listen everything on port 80. So you can have HTTPS also, but we don't have the certificate and all. We'll do it later in another demo where we can use how we can have an SSL certificate. I'll show you that at a later point of time. So this is the configuration, and you want this name to be changed to something else, you can change it. It's just at the end, just a name. That's it. Now, and it's not a service. So when you deploy this Ingress, it's not going to show it as a service, but you have to use a different parameter here to know is there any ingress. There's no ingress currently. What I'll do is I'll just deploy this. Done. Let's just see whether it is showing anything. So started. So it's going to take some time for it to come up. What is this going to create behind the scene is our favorite L7 load balancer, the one which you created in our MIG class. That is what is going to get created. You want to see it? Just go to your network services, networking services. You should see a new entry soon. So these two entries, one is for nginx load balancer, one is for your welcome to containerization for that part. So you should see one more entry soon, folks. Let me just refresh it. And this nginx provisioning is going to take around 7 to 10 minutes. So we have to wait till it comes up. First of all, the IP is still not allocated. The host, if you see, is still not allocated. So let's wait for it. It's going to take some time. I wanted to show you that, whether I can show you that entry here. You see this? This is a new entry. Now look at this. The load balancer which you created is a TCP load balancer, basically and it is regional. The one which we just created is a global load balancer. And if I just click on load balancer details, if I go to my host and path rules, you see this host and path rules. So if it is one, it's going to go to a specific one. If it's /nginx, it's going to go to your different path, basically. So basically to a different path. And this is going to take little time for it to come up. but the IP address is allocated. The IP address is allocated. So if I just go and access it, remove watch command. If I access it, I just going to put it also in the chat. It should usually show error message or page not found is what it's going to show. After sometimes only I should be able to access it. Around 5-10 minutes it takes. It shows like this. So let's wait for it. There's one question from Anil B. Traffic L7 load balancer node port service. So when it comes to yeah, that's the flow. So node port, that is going to go to your service basically. Yeah. So that's going to be the stuff, the flow which you mentioned, it's going to be that way. And the simplistic way to understand the flow is always like this. From your load balancer, sorry, your ingress, which is nothing but your load balancer, it is going to hit your service basically. And these, if you were to ask me, it's going to be something, a combination of node port like this.
So Mahesh, what we understand earlier, we were exposing our services via load balancer. So we thought of, rather than exposing those as a load balancer, we will utilize Ingress provided by Google or others service provider, and that will be acting as a layer 7 load balancer, and our services will be exposed as node port, right? That's what
Correct,
we
correct. I'll
understand.
just show you. So I'll just show you the flow.
Hmm.
Ingress. Then once the ingress comes, so it's going to goes to your node port. Then it goes to your cluster IP. Then the flow goes to your pods. Sorry. This is the flow for your ingress. And this ingress is layer 7, so it has that additional capability of, so it's layer 7, it has that additional capability of host and path rule. So I can have different rules there. So the rule is built here. The rules are going to be here.
Yeah. So what we understand, we don't need to expose our services as a load balancer. We need to expose as a node port, and Ingress will take care
Yes,
of the load balancer stuff, right?
correct. You don't need to
Okay.
have load balancer. So
Yeah.
you don't need to, so it has to be of, the service type has to be node port. And if you
Yeah.
try to do with cluster IP, it's not going to work. The prerequisite is it has to be a node port, basically. Is that clear? Yeah, thank you.
Yes.
So how about the load? You don't need, Deepak, you don't need a load balancer. We don't need a load balancer. And we have kept everything. I can show you everything. We have not created a load balancer. So after we have the this thing running, right, Ingress running, we'll go and dismantle our load balancers. We don't need it. We'll release 2 more IPs and you'll see it's still going to work.
No, but it will create load balancer backend or not, Mahesh?
That
That's
is, okay, we created load balancer. It is still going to be, if you don't delete it, it's going to be still used. If you don't
no,
want, you can remove it.
no. For example, using Ingress, if I have my service is running from US, but because of more traffic, I wanted a load balancer. How that will work if I use
Okay,
Ingress?
so that is, okay, so don't get confused with this. Load balancer is only to, actually the name, actually, if you ask me, the service type load balancer, the name is not a good name actually. You could have given something different for it, but because it does not basically do a load balancing. To be very frank, now if you are thinking of the MIG demo, it's not going to do something like that because it's a regional Kubernetes cluster or zonal Kubernetes cluster. So if you were to do that kind of a load balancing, what you should do basically is have multiple. So yesterday I showed you, if I'm not wrong. So you have something called as multi-cluster, multi-ingress Kubernetes. So you have this option. So multi-cluster, meaning you have multiple clusters and you use Ingress to do this part basically. So this is what you use basically where to serve requests from US, serve requests from Asia, serve requests from Europe. So the base for that is Ingress. You need to know how Ingress works. That's what we are currently seeing, Kumar. And don't get confused with that load balancer term. Basically, is it going to really do load balancing? Basically, I would say it's not going to do. The reason is it is a regional resource. At least with your Ingress, it's going to be much better. One single IP across the globe where you can access it. To some extent, the latency is going to be much lesser if you are accessing it via this global load balancer, HTTP load balancer, compared to your TCP load balancer. Does it make sense, Kumar? Let me just see whether it is working. Is it working or not? Okay, it's working, folks. Now you can access this. This is your our image which we built. Now the other one is nginx hyphen batch 6. Okay, what was the thing which or something went wrong? I should wait, or what was that URL? Batch 6 only. Everything correct. 900 was the port which we had. Was it 900? Yes. 3000, 9000. Let me wait for it. Let me see. It is serving nginx. Okay, let me just see. Okay, I understood it. Index.html. Guess I should have mentioned something like this. I'll tell you what is happening. So if you see here, what you get is page not found, but it is showing it is serving from nginx. The reason is the host and path rule, we have not designed it very properly. So what we should have done is, I'll show you the mistake also. Usually what we have done is, we have just mentioned it like this. So it's better to mention your path like this, anything like star. So that way you should be able to have your request served. So it's going to show welcome to container. What is that? Welcome to nginx, something like that. So star, the path is going to be always important. So if you don't put that path, it's going to become difficult. So let me just do this. This was a mistake I did. Let me just do it one more time. Update my Ingress. So update my Ingress. So it's going to come up. Next, it's going to take time. So once it comes up, we should be able to serve this one. So the whole path is one single IP address, folks. One single IP address with which we are able to serve multiple workloads. So that was the whole purpose of having Ingress here. So if you don't want load balancer anymore, you can just delete these two basically. Don't delete it from here. Release it, delete your load balancer service. It's going to delete this automatically. So this is the whole thing which I wanted to show with respect to the different types of services. And if you want something more efficient, the best option is to use Ingress. And you have different Ingress available from different cloud providers. So let me just give a try. It's going to take usually some time, or I need to check whether I really made something mistake. So the biggest part with your Ingress is it's going to take longer time to set up usually. So you see the complete stuff here, or if you want to click on specifically on Ingress, you can see the stuff, and you see the entire front end, how things have been. It shows you that complete picture. It shows you that complete picture here. And this is always L7 load balancer in GCP global, basically. Let me just stop here for any questions, folks. All the different options, is it clear? Is there anything? So we just need to have, we have this pending. It has to show up. It has to show up. Once it shows up, that's going to be a complete demo. Any questions so far on this part, folks? All the three different options which we have, four different options. Four different options. Any questions? Okay. So if I go to we saw about the details about deployments, the various attributes which is required there. We then saw the various details about our service, cluster IP, node port, load balancer, which is a regional load balancer, and Ingress, which is a global load balancer. Uh, Another way to find out the IP address, right, of your load balancer, whether it's global or regional, you can go look into your IPs. Now you see 1, 2, 3, 4, 5 are there. All are regional. If I refresh this, you'll have one more IP. This is your Ingress IP address. If you just check your chat, but you see it is not mentioning anything here. The reason is it's a global IP, anycast IP. More on this anycast IP concept in our networking class, but this is a global IP. But these are regional IPs. So you will be able to serve this with a DNS, all those things with much faster, which lesser latency, I would say. So that's a main difference when it comes the load balancer. When you create it in the service type of load balancer, when you create in GCP, it's always going to be a regional load balancer, TCP. When you create an Ingress, it's going to be a L7 load balancer, which is global. Let me just give a try if it works, folks. What should I call this? This is working. Let me just see, is there anything which has gone wrong? Or I can try it from here. Backend does not exist. Rule, okay. Slash X. Not working. 1 minute. If I put load balancer, this was our load balancer, which was working. If I do slash index dot, or it could be something to do with the configuration of Nginx. This is working. I'm seeing whether I can do this. Not working. So not working. So I'll try to see.
So
Yeah,
Mahesh,
go ahead.
our node port is if you are directly hitting the node port, right, it is pointing to 80, right? So when we are coming from Ingress, we should point target port as a 80 also, right?
No. So this is how it see. So now, so your first you look into your Ingress configuration. So
yeah,
or before Ingress, right? So look into your So you
Nginx node.
have service port. This okay.
Okay.
Nginx.
I think it's clear.
This
It's
is
clear.
your port. So you have.
It's
So you
clear.
are going to your node port is actually this is not your node port. This is your
Yeah.
cluster IP.
Yeah.
Why? How you are going to access cluster IP your port? Your container is listening on 80. In all of these, how do we look into the logs to troubleshoot it? That's a good question, Anil B. Let me just, sorry, Anil Kumar. How do I see the logs? So if I just go into my, which we have not started. So one option is if you just go to any of these services, Ingress, just click on this. Click on that service. Usually you will have a new feature. This is a recent feature where in that service itself, whatever the service which you have done, you are going to get the logs built in and see what's really going wrong. How do you troubleshoot it? This is one way. The second way is you have a one-stop shop as cloud operations stack driver. So cloud operations, you go to logging, put specifically a filter and get it. But if you want a specific resource, just click on that resource. You will have this tab of logs, Anil Kumar, so and you should be able to get it. Or if you have a complete picture, you just click on this, which take to your stack driver logging or cloud operations logging only. So it's going to just directly take it with all the necessary filters which you need to put. What are those filters? I'll talk about it later in our module 7, where you'll see those various options there. So stack driver logging or cloud operations logging, or go to the specific and click on it. That way you should get to know the log information. Now ours is not working, so anyway you can look into the log to see it. It shows it is updated recently, but still not working as expected. Let me just try once. Not working. Not working. Okay, for a minute, right? For a minute, what I will do is I'll just do this one, folks. Port 80. Let me just try some small thing just to see whether it is to work. I feel it is something to do with Nginx. So if I do this one directly, it's going to be version 3.0. If it is slash Nginx, I'll try to serve it with welcome to containerization. Let me just give that try and see whether we can fix it quickly. So I'll change my Nginx deployment to slightly different. So I'll just copy this. I feel something is wrong with my Nginx there, so I'll just do this way. What I'm going to do is, instead of running this Nginx image, we'll run an older image of our my app 2.1. Now, what I will do is, in my service port of my Nginx, I'm going to make it as 80 because I have my new my app which listens on port 80. So I need to deploy this, then there's a chance my Ingress can start working better. The expectation is if I put slash, it should show welcome to containerization 3.0. If I put slash nginx batch 3, it should show something like welcome to containerization. That's what I'm expecting. So let's give a try. If it does not work, I'll just check it out later. So you need to change the app name. Not required. So in my deployment.yaml, my label is nginx still. My label is still nginx. What my service is going to look for. So I don't need to change it, Kumar. So it is still nginx. So it should not be a problem. So let me just try k deploy minus. Even though it is nginx, it's not nginx content. That's one thing. I wanted to then deploy my service. No, not this one. Done. So it has been updated. Let's wait for it to show up. Let's wait for it to show up. If things are all fine, this one should basically give welcome to containerization. Let's wait for it. It's going to take some time. By the time that comes up, I just wanted to talk about something. So it's going to take time. Ingress are usually time consuming stuff. We'll just look into this and then take a break. Maybe before that, if it comes up, I can show you that. So the next one is something called as stateful set. Now all this time when we were doing where, yeah, go ahead.
It's coming, I believe.
Sorry. Is it coming?
One second, I saw some. Yeah, if you check, it's coming, I think.
Okay, if it's
If
coming,
you
I'm
put
happy.
slash,
I'm the happiest person.
I'm just
Without
giving the. You need to give one more backslash, front slash. Let me give you over the chat. 1 second.
Awesome. It's working. I saw that.
Yeah.
It's working. So that is one thing. And if you remove basically and use it, 2 versions served. So makes sense. Thanks Anil for checking it. So now makes sense, folks, how it's working. Maybe something with my Nginx. I have to check the configuration of Nginx. How do I do this ingress part with that? But since we had our image, 2 images, we saw with same URL, sorry, same IP address, different the pattern, the URL, the context with which we can have different versions served basically. So this is something which I wanted to share. Now you don't need any more your load balancer. Go ahead and delete your load balancer. So let me just delete this load balancer. So how do I delete it? Well, just put k get svc. K is a proc alias which I've created, folks. So when you are doing it, you have to do Kubernetes fully. So delete svc load balancer. So just copy the name load balancer. I don't need this. Similarly, I may not need this load balancer also. So which will release 2 IPs for me. So which is going to save some cost basically. So I just need an ingress, nothing else basically. So hope this concept is clear, folks. And I've seen many trainings don't touch upon ingress, but which is an important one when you real implementation. So just wanted to talk. I'm not sure whether how much you are going to get it in the exam on ingress, but for your real implementation, it's always going to be ingress. So without doing that, I feel like I'm not doing a justice. So that's the reason I explained the ingress part basically there. So no more load balancers, but I just have my ingress. So ingress is good enough. Yeah. So let's just verify whether it is still working. Sorry, not this one. This is working good. It's also working. Awesome. So this is work. Now we'll just go through the slide and then take a break, folks. Now, so far, whatever you did was a stateless application. So it never keeps you the state. Basically, there's no database behind the scene. Welcome to containerization, a very simple application, a hello world kind of an application which you build. No state is preserved. So, but if you were to deploy you know the concept of containerization, and you can also containerize a database, MySQL, Postgres, you can easily containerize it. And there are marketplace options where you can go and deploy that also as a containerized app. So if I just go to my marketplace, we have explored marketplace in the in the context of virtual machine. You can also explore marketplace under the context of a Kubernetes. So if you just go to Kubernetes and click on marketplace from here, it's going to explore all the Kubernetes apps which you can run on a Kubernetes cluster. So we're going to have a filter which is going to be put on Kubernetes app. So if I search for MariaDB, so this one you see, this is MariaDB, which is going to get installed or get deployed on a Kubernetes cluster. So when I click on configure, it's a Kubernetes app. So if I click on configure, it's going to tell me in which Kubernetes cluster do you want. So it asks for a Kubernetes cluster, or you want to use an existing one. So this one basically is a stateful application. Why database is a stateful? It's going to process that information in tables, right? So it's going to keep that information. So this is basically a stateful application. Now, if you want to have a stateful application deployed in Kubernetes, the best way to use is a stateful set. So this is another kind of an object which is basically for stateful applications like any database, MongoDB, MySQL, Kafka, anywhere you want to process this information, you will use stateful set. And one important advantage of the stateful set is pods will go down, come back, all those things. As we know, pods are mortal. It is not immortal like God. It's mortal like us. Pods are like us. Uh, it will go down, come back, all those things. Whenever it goes down and comes back, we have seen in our deployment, right? It comes up with a new IP address. It comes up with a new name. So it's not unique, it's random there. But when you're doing with a database, right? So you will have lots of requirements where the host name should be the same. The pod name should be the same. All those requirements would be there, and it has to connect to the right storage. All those kind of a requirement would be there. So that's where that stickiness comes into picture. So it's going to have that stickiness where it's going to give the, even if the pod crashes and it comes back again, so this pod goes and comes back again, it connects to the same storage and gets it. So that's where stateful set comes very, very handy. And instead of me explaining this one, right, I saw a video, folks, mind-blowing video. It is around 15 minutes, the video. I'm just going to put it in the chat. 16 minutes. I would strongly suggest you to look into it, please. I thought I will not do a justice when the kind of demo which this person has done is awesome. And the content is too good, I would say. It was so nicely explained. So I usually do it in a different way, but this one was too good, I thought. So instead of me explaining it, watch this video and you'll get the concept of stateful set very easily. So basically, in a nutshell, it is for stateful applications. Whenever you have a database, you have to persist the information, all those things, and you are deploying it in a Kubernetes cluster, prefer to use a stateful set. So this is again a kind of object. How do I create stateful set? Simple. Go to your this thing editor, create one stateful set dot YAML state yeah, stateful set stateful set. Do I have seen once. So stateful. So the kind of object is going to be stateful set. Basically, that stickiness is going to keep the host name, everything is going to be retained, the IP address, all those things are going to be retained. So this is going to be really helpful for applications which is going to maintain the state like a database. So I would strongly suggest to look at this video. One of the nice videos which I have seen on stateful set. So that's on a stateful set. I'm not going to do a demo on this. Look into it. If it's not clear, maybe next week you just drop me a mail that this was not clear. I will do a demonstration. I usually do a demonstration of basically this DB, where I explain it via demonstration. Like when I delete the pod, what happens? It comes back again, but still I have the content there. So you have a storage, persistent volume, basically called as in Kubernetes, and you are going to have a kind of deployment, sorry, kind of object is stateful set with which the stickiness is maintained. In stateful, the IP will retain, and we are saying internal IP, right? Yeah, that IP is always going to be your internal IP. That's going to be a cluster IP, basically. It's going to be always cluster IP. So this could be very helpful, and this video, the person has explained it very well. I will really look into it right after the class. It's going to help. So what we'll do now is we'll take a 10 minutes break, folks. Once we come back, I have one small slide on Kubernetes. We'll finish it and move on to the next component, which is App Engine. Okay, so take a 10 minutes break and come back.
This conference will now be recorded.
So before the break, we saw what is stateful set. Basically, the key part is to retain the IP, the host name, basically the host name, Then I guess the IP part I'll Anil, I slightly doubt. I'll just check it, but the host name should be uh, retained is my understanding. I'll just check the IP part. Stable host name. The stickiness is going to be maintained there so that even if it crashes, comes up, the pod comes up, it's going to retain those information. So that's where stateful set comes very handy, usually useful for uh, deploying database apps on Kubernetes. So that's where this comes. The IP part, I'll come back, Anil. I'll just check it. I'm not very sure whether the IP is going to be retained when the pod comes and goes. It may not be, but the host name is going to be retained. The host name is going to come from your pod name. So the host name is going to be there. So a small question. Um, Your application uses Kubernetes to manage several workloads. One workload, maybe a specific workload, there are multiple workloads. One workload requires a consistent set of host name even after the pod scales and relaunches. So even when it scales, the cluster IP, yes, the cluster IP part, I'll just get it. Yeah. So anyway, I'll just check the pod IP. The cluster IP is going to be the same thing, but the pod IP, I just need to check it. Yes, so what's the answer? Anil Kumar got it. Vivek got it. So straightforward one. And I've tried to highlight also the important stuff which you need to look for this one. Uh, Consistent set of host names, even after the pod relaunches, crashes, relaunches, all those things. So what's the option which you're going to use basically? Straightforward answers, but these things sometimes if it's not covered, you should not lose it out. So just want to share you that there's a concept for full set there. Only three response was a very simple question, folks. Or maybe people are not back from the break. Okay. Anil Kumar, Vivek, Anil B, Kumar, uh, Anil B got it correctly. Stateful set. The answer is simple. Stateful sets is going to help you out to have that consistent set of host names. So sometimes looking at your documentation is very, very helpful actually. If you ask me, the content which I pasted here was just a copy paste of the documentation only. So it was a paste of the documentation which mentions the specific word, persistent and stable host name, which is going to be with your stateful set. Now, coming to the last component or the last concept in Kubernetes. So, how do I change the machine type of a node pool? So, if you have a machine type and you want to change the machine type, maybe you started with G1 small, later you don't know because the load is too much, you are not able to handle it, so you wanted to change the machine type of it. Then how do I do it? So when you were to do something like this, the machine type, just go and check it. Yesterday itself we have given a try. Let me now one more time give a try. Compared to yesterday, today we have more concept. So the question is something like this. So if I just go to my code, my bad, to the cluster and look into my nodes, the configuration of my node pools are, there are 3 nodes in this pool and each is of G1 small. Now, this machine type is not fulfilling my workload. My workload is little memory intensive. So I want more better configuration, better machine type. It's not N1 standard, maybe N1 standard 4 is what I wanted. Now I cannot change it if a node pool is already created. If you see here, click on edit, the machine type, I will not be able to change it. I'll get that option to change the machine type. So I can just increase the number of nodes, enable auto scaling, all those things, but I cannot change the machine type. I cannot change the machine type. Or if I go to my Kubernetes page itself, sorry, Compute Engine screen itself, and try to edit, stop and do it, even that is not possible because it's a managed instance group. Let me just show you. So if I just see, change add a column, in yeah, here it's the machine type is G1 small. So if I want to change the machine type, I have to stop it. I cannot stop it because it is managed by an instance group. Now, the only way if you do it is basically you need to modify this template. And I would strongly suggest not to do all this kind of a stuff because infrastructure should be basically the VM should be abstracted. That's the whole reason why people go to containers. They don't worry about the infrastructure part. Basically, it should be abstracted. So in that case, the best way you can do is, what you can add is, because you have one node pool which is of G1 small configuration, which is not fulfilling your requirement, please add a new node. Click on new node pool. You mention what is the configuration you want. So give a name, then node configuration. Make a better configuration. N104 and provision it. And provision. Now you have two node pools. Now what you do is, there's a concept called as cordon, C-O-R-D-O-N, cordon those existing pods and move all the pods which is there in default node pool to the new node pool which you have created. So this way you would be able to migrate your existing workload which is running on a low end machine type to a better machine type. So this entire stuff is done this in a video. So if you are interested, you can look into it. Um, so if I just go to my yeah, so if you just search for cardon, you get that video. Let me just show you. I've never seen any questions on this, but in your real implementation, you are going to use this. You will make mistakes, and it's a 7 minutes video. So strongly suggest you to look into this when you want to change the machine type, basically, of your worker nodes. So this is going to help you out, and if you want, you can give a try also. I had used this very heavily in one of the organizations when I was doing it because the information was not much clear. So I had to start very small. Then slowness was there in deploying the modules or pods. Have to do this cordon multiple times. So I have to switch, create multiple times a node pool there to do get it. If you get the right requirement, you don't need to do it. But this is where if you were to change the machine type, you have to use this option. Okay. So I usually play it on the video. So if you are not interested, you can look into the video later. And there's a short link also in the slides. You can refer it later. So this is on the machine type, changing the machine type of specific node pool. So basically you cannot change it. Literally, you create a new node pool, migrate all the workloads to this new node pool. Basically, that's it. So once you do that, things are going to work. And at the end, if you don't like this older node pool, delete it, basically. So the entire step is mentioned here. Look into it. This could be helpful for your real implementation. So I can just copy this link and put it in the implementation document for your reference. So to change the machine type of a node pool. 15 and 17 have a custom script to delete older containers in GCS so that the okay, fine. Both are same. Yeah, correct. Fine. No worries. Thanks for highlighting it. So that's on Kubernetes part, folks. That was the last slide which I wanted to show on the Kubernetes part. Now, when do you think you should go with Kubernetes? When do you think you should go with Kubernetes, first of all? Any thoughts, folks? When should you go? Now, like how we did in Compute Engine. When we finished the Compute Engine, towards the end, we saw when to use Compute Engine. So when should you use Kubernetes engine basically as a first question? So when you don't have a software, sorry, I did not understand. If you don't have, I would say you don't need anything. So I don't need any infra itself. So Deepak's point is good. When containers are involved, microservice based solution, okay. Low operation work, auto scaling for containerization, all those things with load balancer, good. First of all, when can you use Kubernetes? First of all, folks. First, the application should be containerized, right? So it should be containerized. If the application cannot be containerized, right, forget all the concepts which you learned. You cannot use it. There are few workloads which you cannot containerize itself. So you should be able to containerize it. If you cannot containerize it, you cannot. So I can just give you an example where one of the app I was not able to containerize it. The only reason was it was a commercial product, licensed product, which expects a specific license attached to the MAC address of the machine on which it is running. So it was very difficult for us. There are few options is what I heard recently. So if there's a virtual machine, there's going to be a MAC address for it. So the MAC address is what is the license attached to. So this pod is mortal. It will go down, come up, all those things. I cannot have a specific MAC address for it. So that was the reason why we were not able to containerize it and run it in as a containerized model. So there are scenarios where you cannot use this containerization concept itself. So if you cannot containerize it, the fallback option for you is your good old friend compute engine. So you have to go to your compute engine back there. So first check whether the workload can be containerized. If it cannot be containerized, please don't even think of Kubernetes, think of your virtual machines. So as long as the software can be containerized, yes, I have a great chance of doing it. And one small tip which I can give to check whether the application can be containerized or not, simple. You ask the question to the customer. So like, uh, what's your application? If they say we have a homegrown application, there's a high chance it can be containerized, because usually homegrown applications would be using open source products. So no license anything. So there's a high chance it can be containerized. But if they say it is a commercial product from XYZ company, then you have to look uh, into this website. Usually this could be helpful. So your Docker Hub, you just go to Docker Hub and see whether that specific app can be containerized or not. For example, I usually get questions like, can I containerize an ERP system? Is ERP, usually it's a Java based application if you see at the end. So what I usually do is Tableau. Sometimes they ask, can Tableau be containerized? I whether it can be containerized because it's a product specific stuff. I simply come and search Tableau here, and I get an idea whether it can be containerized or not. So it may not be an official support, but looks like there are people who have tried to containerize Tableau server and Tableau client. So that gives you an idea. Yes, it is possible. And if you just search for some ERP, you get something which is possible, is not maybe a specific ERP from Oracle, but there are possibilities where you can do it. So this is a hint, folks. This is a hint, whether it can be containerized or not. A commercial product, for example, Oracle. So Oracle DB. Not so good at Oracle, so Oracle database, let me see. Not getting, okay, Oracle database, yeah, Oracle database with respect to your, it is a verified image. So you can containerize, it's already there. So you just pull this image, run it in your Kubernetes, it's going to work. So with the specific license or anything which you need to add in. So it's going to work. Similarly, if you try MySQL, you have an official image, so you can run it as a containers app directly there. So this is going to be a good starting point for you to see whether the app which they want to run, whether it can be modernized, can be run in a container or not, basically. So that's where this when to use comes into picture. And if whenever you hear from the customer agnostic, environment agnostic or cloud agnostic kind of a requirement, I would always prefer to use Kubernetes. So I will always use Kubernetes. The reason is I have seen this in my own experience. So when I was working in a service-based company, so first time they had an application, a microservice of not one, I guess 11 microservices. It was something like an Uber Eats kind of an application. Uber Eats kind of an application which needs to be deployed. So they did not give any information whether they want cloud native or cloud agnostic. So it was a Java based and some Node.js based application. Okay, the backend was Node Java, front end was in Node and Angular. So just gave me the details about this is what needs to be deployed. So and it was in GCP. So I just simply deployed it in App Engine, which we are going to see in next few minutes. So later, 3 months later, they came back and told Mahesh, we may move to AWS in next few months. So we don't want to use any native solutions. If you use native solutions, you are going to have a vendor lock-in, meaning App Engine, which you are going to see in the next few minutes, is a native solution, meaning App Engine exactly you will not get it in other cloud. You get a flavor of it. But if you have containerized it, you get a same kind of containers option in other cloud also. You get Kubernetes offerings in AWS, in Azure. So whenever they say cloud agnostic, I would always prefer to use Kubernetes there. Container concepts is going to be used basically. So if the customer says I want cloud agnostic, prefer to use GKE or container concept. So tomorrow they don't like GCP, they want to go to AWS, fine. So they can access the container registry and they should be able to deploy it easily. So that's where Kubernetes comes into picture. Cloud agnosticness when you want, and if the application can be containerized, go for this basically. And this is going to, I currently see most of the industry, most of the organizations are containerizing their workload, and there are tools to automate this also. Various cloud provider provides it. GCP also has one called as Migrate for Antos, which helps you to migrate from a virtual machine content into a containerized based app basically. So that's something on Kubernetes, folks. A little longer module because it requires some prerequisites also. So we spent some time on containerizing itself. So it took time. So there's one question in the chat where Anil Kumar wants an explanation of what is a monolithic application, what is a microservice based application. So for this, I usually take this example. Let me just show you this example. Istio. There's a very nice diagram. So let me just explain it. And whenever it comes to Kubernetes, whenever it's a microservice, Kubernetes comes handy. So what is microservice? First, let me explain you that. So there's a nice diagram. Anyway, we are not discussing history, but I'm just going to use that image, folks. Let me just get you that image. You. Uh, Sam book info. That's very nice to easy to explain. So let's explain it. Uh, yeah, that's the image. This is the image. I'll put it in the chat also. Usually to explain my service versus monolithic, I usually use this. So open a new tab. And whenever it is microservice based architecture, right, Kubernetes comes into picture. So what is microservice? First of all, let's try to understand. So this is, before we go into this image, right? So usually people in the beginning used to dump everything into one single code base. So monolithic. So if you have an app, say for example, banking application itself, you take a banking application, and if it's banking, people usually prefer to use Java, and the backend database would be usually Oracle. Standard rule, standard. This is what I have seen, Oracle. Now, if it's a banking application, you'll have lots of services in it, right? Open account. This could be one service. Then credit card specific services, open account service. These are various services. Like you can treat this service as if you go to a physical bank. Uh, Not most of us go these days, but at least in the I have seen it in many nationalized banks. You will have different uh, people sitting in different blocks where this is for credit card, this is for home loan service, this is for savings account. So they will have different services, right? So if you try to convert that into an application, you'll have different services which you're going to do. Savings, and in then after you open the account, you may have some uh, withdrawal service and deposit service. You'll have lots of services when it comes to an application. So because it's a monolithic, meaning once very powerful application, everything is written in Java. Language is just an example I'm taking. It could be in .NET also. But usually banking application, they write it in Java, and many people think Java is very secure. I'm also of the same understanding. So it is written in Java. Everything is there. Now, tomorrow, say for example, you have a uh, promotion stuff needs to be done in your bank because you're launching some service, maybe with the bank and some with stock market or something. You're trying to do something, you're trying to launch a new service. So you are going to add that something like trading. Let's do something like trading service. I see these days many banks are doing it. Now, this is a new service. Now, because it's a monolithic, you will have to have a downtime because everything is packaged as one single deployment, usually called as .ear, an archive file or a slash war file. It's basically a zip file kind of a stuff in very simple terms where all the stuffs are packaged and deployed. But everything is one single. It's like basically all the components, all the functionalities put in this code. Now, if you were to do even a small change, the entire application has to be redeployed. So this is your monolithic application. Usually, this is one powerful stuff. Now, later people realize that if I were to have some bug fix for a deposit service, why should my withdrawal service go down? And at least to some extent, withdrawal and deposit are related. But if I have a bug in deposit service, why should my credit card service go down? Which was not even acceptable, right? Because it was all one single application, you have to have a downtime. So that's where people came up with something. This is monolithic, folks. This is monolithic. I don't have a slide. That's the reason I'm using this. It's monolithic. Now that's where people felt, let's break this into pieces. I would say it's monolithic in a very simple term. It's like your joint family. It's like a joint family. Everything is there. So fun is also going to be there. Problems are also going to be there. So the communication is going to be very easy. So people inside the house, they easily communicate, meaning the services inside is going to communicate easily. There's no network latency. Your microservice based architecture is totally opposite. The nuclear family example. So microservice. So here, what you will have is you will have different services split across different compute options. So you would have split everything, and you will be running as different pods, basically, at least with the Kubernetes comps, or with your virtual machine, individual virtual machines you'll be running. So if you have a credit card service, basically you only deploy there. Only the credit card service is going to have a downtime. All other service is going to continue working. But with your microservice, everything is going to be in two different pods, all those things, right? It is like your uh, nuclear family, where people are going to be in different houses. If they were to communicate, they have to use a medium, right? So there's going to be latency. So with your microservice, because everything is going to be deployed in different pods, network latency is going to come. But the advantage there is, if I have a downtime if I were to deploy a specific pod, only that pod goes down. The remaining service continues working. So this is going to be a good fit for Kubernetes to pitch in. So I create, and because it is split, you can basically write code in different language. If it's monolithic, basically you have to write everything in one language. But if it's a microservice, because it's split, I can write different components in different languages. The backend stuff, I can write it in Java. The front end one, I can write it in Python. So that's going to be a good option here. So, and I can scale it very easily. So say for example, there's one service product page. Many people come and look my product page or my home page. I scale this. It's a different microservice, but many people don't do any transaction. Maybe this could be running at a minimum level. So in a very simple terms, it's a comparison between a joint family and a nuclear family. So when it comes to monolithic and microservice based, microservice, whenever you think of, Kubernetes comes into picture, basically, folks. And the network latency, all which I mentioned here, uh, is going to exist in microservice. It's not that microservice is the best option. There are situations where people still prefer to use monolithic. There are situations where people prefer microservice based architecture. And now there's a new service type coming. Already people are using it, called as nanoservice. Where that network latency and all are going to be to some great extent reduced. But for microservice, the best way to deploy it is always containerize it. Containerize all your microservice, deploy it on Kubernetes there. Hope that explanation helps you, Anil Kumar. So Kubernetes comes very handy when it comes to microservice-based architecture. And if it's a monolithic, it's preferred to run it on a virtual machine, basically. Okay, so that's something on the microservice-based stuff. I usually use this. So it's very easy. You see one application. This is just a book info application. If it's a book info application, you have a product page, you have some review page, you have some ratings, details about the product. So everything is written in different languages. It's usually called as polyglot, where one application is written in multiple languages. The another advantage of microservices, you don't enforce the developers to write everything in one language. If you're good in Python, go and write it in Python. If you're good in .NET, you write it in .NET. So that freedom is given to the developers. So another simple example, if I were to give is microservice versus monolithic. So if it's a joint family, everybody cooks one dish. So everybody are forced to eat the same thing. But if it's a nuclear family, so they can prepare their own food of their choice. So that luxury or that freedom is there. So it's just a comparison there. So handy option when it comes to Kubernetes, it's going to be your microservice based requirement comes. It's always going to be your Kubernetes comes handy. Application can be written in multiple language as so you have microservices, right? You have these many microservices. Account opening, it's a one service. Now this has to be something as a front end, so there should be lots of forms, all those things. Deploying this, it is called as polyglot. So okay, polyglot. This is what is usually called as polyglot. So if you write in multiple languages, one application, it's going to be polyglot. All right, so that's something on the microservice base, microservice architecture. And who is going to decide whether it's going to be microservice based or monolithic? It's not you. It's not cloud architect. It has to be something like an application architect. Who's going to build the application? It's going to be decided by them. If you want, you can give your thoughts, but it's not our stuff which we need to do. So it's going to be application lead or application architect who is good in writing, helping the team to write code in a language of their choice. So that was our last module, which was GKE, which is basically container as a service. Now, moving on to the next part, which is App Engine. This is also one of the compute options. This is platform as a service, where everything is going to be managed by us, and we will never go create a virtual machine. No, never go create a Kubernetes cluster, all those things. So it's going to be so easy here. Only focus on code. I would say this is going to be more helpful for developers, application developers, where they don't need to worry where my code is going to be deployed. Should I delete it? Should I stop it? All those concerns are going to be totally remote. You just focus on your code. Just write your code in a way it is very efficient. Just go deploy it in App Engine. And the equivalent of this in your AWS is called as Elastic Beanstalk, and in Azure it is called as Azure Services, App Services. Focus only on code, nothing else. But a word of caution, it is a native solution. If you have deployed something in App Engine and you take it as is and put it in AWS Elastic Beanstalk, it will not work. You have to do some modification there. But if you have a container image running in GKE, you just get it, put it in EKS, Elastic Kubernetes Service, it's going to work because it's been packaged in that fashion. So, and it is cloud agnostic. So this is cloud native solution. But whenever you go with cloud native solution, one advantage which you get is very much cost optimized. So it's very native, right? You are going to always get that benefit. But when it is native, the problem is there's a vendor lock-in. So App Engine is available only in GCP. You may get a flavor of it or an equivalent of it in some other cloud, but you have to do always modification there. Okay, so that's something on App Engine which we are going to talk in next few minutes. But before we go into the next slide, we did not delete our cluster. We have provisioned our Kubernetes cluster with gcloud command. So why don't we delete it once using command line? In the UI, it is easy. Go click on delete cluster, it's going to work. And a Kubernetes cluster cannot be stopped, folks. It has to be only, you can only create it or you can delete it. It's not like your virtual machine. Okay, so if you're not running, if you're not using a cluster, please go and delete it so that you can save some cost. Okay, so let me just do this part. I forgot to do this. Slightly a jump back to the previous thing. So let me just go back. So let me just delete this and then we'll go to App Engine part. So there's an instance which we have, cluster which we have. So let me just delete this. So reconnect back. And all the demos which we saw in Kubernetes, in Compute Engine, took a good amount basically. The infra needs to be provided. You have to have lots of components. But as we progress further, right, with App Engine, cloud functions, cloud run, I would say the demos are going to be 10 minutes, folks, because they are already like at a high level. These are all platform as service, which becomes serverless products. So it's going to be very, very fast. So let me just delete my cluster. I'll talk about that when we do it. When we talk, we have not come to that, Kumar. So when to use this GAE? So we'll talk about that. So class Cloud Shell container clusters, delete the cluster, and the name of the cluster is dev shell project ID CLI, if I'm not wrong. Yes, that's the one. CLI, and you have to always mention the zone even while deleting it. Otherwise, it will not know in which zone it is. Okay, thank you. Southeast 1A, and it's going to always ask for a confirmation. So I'm going to silently delete it. So let's put time also and just see it. So that's it. So that's going to delete my Kubernetes cluster, a command line way of deleting it. So we provisioned it yesterday. Today we are deleting it. All right. So it's going to take some time to get deleted. Just it was a last part which we had to do. So just that part. So everything. Now coming back to App Engine, the focus is always with respect to writing a code, nothing else. You don't need to worry where my code is going to get deployed, how scalable it is, the environment is, what will happen if too much request comes, what will happen if no request comes, how will my infra work. I don't need to worry about anything when I'm focusing on GAE, Google App Engine, and the focus is only on code. And just for your information, this is the first product which Google launched in 2008 or the first product. And the first product itself was App Engine, basically, which is platform as a service, where in 2007, people were not even looking at products which is serverless platform as a service. Google launched at that thing. But to be very frank, at that time, it was a flop. It was not a hit actually. So people were not even recognizing that there's a value in this. They were expecting, we want virtual machines. You give us virtual machines where our application runs. But Google was little advanced, and they were saying, you give us the code, we will deploy and manage it for you. People were not understanding. It is like, not sure how many are fans of Kamal Hassan. It's like Kamal Hassan movies, like movies where he has done in the past are at least like 10 years, 10 plus years advanced levels. At that time when you launch it, it was a flop. For example, Hey Ram movie, if you I had seen it, so there was a myth that you need to know 5 languages to understand that movie. It was a classic movie, but people did not understand at that time. Now, after YouTube coming, lots of reviews people see, they go and look into that video. So it was the same case with Google. They launched platform as a service at that time where people was expecting infrastructure as a service. So you have to give the right product at the right time, basically. And Google, they themselves realized that they made a mistake, a blunder. The CEO itself had mentioned that it was something too much at that time. That could be one of the reasons why the adoption of Google was little less during the beginning days. Now Google has a different strategy altogether. They are focusing more towards multi-cloud, support for multi-cloud, all those things. That's why they are focusing more towards containers, Anthos, all those kind of stuffs. Slightly out of topic, but just wanted to say a history about this part. Now, when should you use this, all those things? Before we look into the app engine details, all those things, there's a concept in cloud called as serverless. So the serverless term itself is a marketing term. So just to indicate, attract people, serverless. Meaning what it means is, as a customer for you, you don't need to manage any servers, any infrastructure. But as a cloud provider, there is lots of servers which they need to manage. But I'm least bothered how much servers you are going to manage as a cloud provider, because that's your bread and butter. You are going to manage it. But as a customer, I don't want to manage any VMs. I don't want to manage any Kubernetes cluster. I have a code. I want to run it. So I have a data. I want to run some analytics on it. I have a code which I need to publish it. So, or I have a code which needs to do some machine learning. So if that is the kind of focus, you will always prefer to use serverless products. And in other cloud, right, AWS, Azure, let me make a name, no problem there. So you will have less serverless products. So maximum what you will have is a storage. AWS will have S3. In Azure, you will have blob storage. And under compute, you may have AWS Lambda, Azure functions. That's it. You will not have any more further serverless products. But when it comes to GCP, right, you get a database, a data warehouse which is serverless, a messaging service which is serverless, a database, basically a NoSQL database, which is serverless, ETL tool, which is serverless, and lots of serverless compute options. So machine learning also, you can do it in a server mode. You don't need to worry about the infra. Just focus on your code. What is your business outcome? That's the beauty. So I would say the only cloud provider who has lots of serverless products is GCP. So what are the products? If you are very curious to know under compute, what are the products which we are going to discuss? It's going to be our App Engine standard, Cloud Functions, and there's a new product also called as Cloud Run. So this comes under your compute option. A database which is serverless is called as Firestore or Data Store. A messaging service which is serverless is PubServe. A data warehouse which is serverless in GCP is called as BigQuery. A storage component which is not something unique, other cloud also has it, Google also has it. ETL2 which is serverless, data flow. Machine learning which is serverless, M engine. So you get lots of products in GCP which serverless. This is the coolest part, I would say. Meaning you focus on your business part, never focus on infra. But the word of caution is, whenever you use these serverless products, there's a native cloud. These are cloud native, GCP native solutions. Vendor lock-in is going to be there. Now we will cover all these products, folks. Don't worry. But since we're into compute option, focus is going to be on this two modules, along with one more as one, which was launched 1.5 years back, Google 2019 Google Next event. So it's becoming very popular these days. We'll talk about that in our next class. So today we'll focus on App Engine, and in App Engine there's a specific flavor called App Engine Standard. Only this is serverless. Okay, so now let's look into what is App Engine. So App Engine, what you can deploy in App Engine is basically a web-based application. Basically HTTPS based applications, web-focused applications. Now, if you ask me, can I deploy a database in App Engine? Answer is wrong. The reason is because database is TCP based. So layer 4, if I'm not wrong. So HTTP is going to be at your layer 7. So web-based applications can only be deployed on App Engine. Database, you have to use something else, maybe a virtual machine or a Kubernetes cluster. So if it's a web-based, any web-based application, it could be a microservice based stuff. It could be a web app or a web service. Web app will have UI. Web service will not have a UI. It's going to be JSON format or XML format. So anything on web, App Engine could be a good choice. So what could be the possible stuffs which you can use when it comes to App Engine? So assume an example, a hypothetical scenario. You are working for, is for everybody the voice is breaking, folks? Is it better now by any chance? Folks, is the voice breaking or is it okay? A bit, okay. Fine. Okay, fine. Okay, thank you. It's now better. Okay. Some network glitch. Okay, so let's take a hypothetical scenario. It's a bank. Now they wanted to move to GCP, and if it's a bank, definitely they're going to have a web application, and they will have a database. Simplistic. They will definitely have a middle tier. So let's put that also. Something like Finacle from Infosys, something like that. Okay, so you have these components in a banking application. So now this could be written in Java. Now, if I were to migrate this entire stuff to cloud, what I will do is this one, I'll put it in App Engine. This one possibly could be put in App Engine again, but I need to do some investigation. And if it's a database, no, I cannot put it in GAE, but possible in your GKE or GCE. So only web-based protocol should be HTTP or HTTPS. Simple, folks. So only that can be deployed on App Engine. So the smallest unit is always application, a web-based application. The trigger, you are going to call this via HTTP only, nothing else. So the best option is for migrating any web-based applications, you are going to use App Engine, basically. Now in App Engine, you have two flavors. One is called as standard environment. The other is called as flexible environment. So in standard environment, right, usually because this is focused on web application, Google provides you some support for some specific languages. If it's a specific language you need to run, you need to have a runtime for it. If it's Java, you need to have a Java runtime, JRE. If it's Python, you need to have a Python runtime. So the runtime support is very, very important. Google provides this support for some few languages. Go 1.9, 1.1, 1.12. And to be very frank, you don't need to remember this slide for the exam books. Don't need to remember it, but this is for your implementation purpose only. So there are support for language Java 8, Java 11. I guess the latest version of Java, if I'm not wrong, is 15 or 14. So there are certain language for runtime support: Go, Java, Node, PHP, Python, Ruby. Languages are there. So what language is not there? Anybody wants to give a try? What language is not there? Very powerful language which is not supported in Google currently in standard environment. Any language which comes to your mind? Java 2 version. The second version of Java is not there. Python, I'm never heard of Python 1.x. That's not there. .NET, Microsoft based one, that is not there. There are other languages like Perl, Lua. Lua is a language which is extensively used for gaming and all. Those languages are not there. Meaning, if you have a web application which is running in Java 2, at least when I was doing my engineering, Java 2, J2E was a very popular term. The 2 indicates the version actually. So J2E application you would have heard of. Now it is called as JEE, Java Enterprise Edition. So usually they used to call it as Java 2 Enterprise Edition at that time in 2000 to 2005 time. So those are not supported. So these are the specific versions which it supports when it comes to standard environment. Now, why Google puts the specific constraints here is basically they have created a sandbox environment, something like very strict, where there are very little knobs which you can modify. So very good constraints are there, and these constraints have sometimes an advantage, sometimes a disadvantage. The advantage is they can scale down to 0. That is what you see. Scale down to 0 is something which you will never see in even in AWS, folks. AWS Beanstalk, it will never scale down. You have to do some extra work, but here without doing any extra work, it will scale down. So what do you mean by scale down? The web application scales down to 0. Today is a Sunday. On Sunday, 6 o'clock in the evening, nobody is going to open up your application. Then why should an instance be running? You can scale down to 0. So if you scale down to 0, what's the benefit which you're getting? Zero cost. Literally $0 is what you're spending on that day. So scale down to 0 is the coolest feature which you get in App Engine Standard. Another advantage of this sandbox, the constrained environment, is it can rapidly scale. Remember, our virtual machine scales up or can be provisioned in 30 seconds or 10 seconds at the quickest. You can have App Engine Standard environment provisioned in 30 milliseconds. 30 milliseconds easily. So it can scale up rapidly, and if there's no traffic, it will scale down immediately. And it will scale down to 0 after 24 hours if there's no traffic. So that kind of a capability you get because of this sandbox environment, constrained. But what are the disadvantages of it? You cannot use a language of your choice. No .NET support. Even Java 2 I cannot use. Java 5 I cannot use. Java 14, the latest version, I cannot use. Node.js, if you see, latest version of Node.js is 15. I cannot use that. So these are the constraints which you get when it comes to the sandbox environment. So now, if you have a web application, the same example, application, it is Java, but it is .NET. It is .NET. Then App Engine Standard will not help you, but rather App Engine Flexible is going to help you out. So Flexible, the name itself indicates you can use any language, the standard languages which is there, or any custom runtime. Google is going to help you to provision that. I have personally ran a C++ application which listens on a specific port, HTTP, so port HTTP:// some 20,000 or something. You can deploy any application, any runtime in App Engine Flexible. So there's no much constraints there, and it's not a sandbox environment, but it is nothing but, in very, very simple terms, a virtual machine, a managed virtual machine. So because it's a virtual machine, they have given you lots of freedom there. So whenever that freedom comes, you will have to pay some extra cost. So meaning you cannot scale down to 0. An App Engine Flexible can only scale down to minimum 1 instance. So even if there's no traffic, App Engine's Flexible instance is going to have 1 instance running. But if you see standard, it will scale down to 0. It can be really helpful if your website is a low traffic website. So a low traffic website, for example, are admin portals. If there's a website, there's going to be an admin portal for it. People log in, very few people go to admin portal because the number of admins are less. So, but for the main website, many people log in. So you can have your main application running in App Engine Flexible. If it's an admin portal, you can deploy it in Flex standard environment. For example, just to give you an example, there's a web application which has two components: front end, which is user facing, and the admin, where give access all those things, admin portal. So there are two parts. Now if this app is written in .NET, you deploy two different services. This is also in .NET, this is also in .NET. What I would suggest is this can continue as .NET only in GKE Flexible. But this one, because it's a low traffic portal, very less traffic comes. Only whenever you need to add an app, people, you go there. So in this case, I would strongly suggest do some change in the code. Change it to any of the language which you see. Any of the languages which you see is the specific version. For example, Java 11. Then deploy it. Then you are going to get some benefit of that. So this is where you can provide such suggestions. If the lead, what is that? Uh, the application lead or the application architect comes and asks you for suggestion, this is where you can give the language specific stuff. At that time, this version data is going to help you out. So two types of environments which you get. One is a sandbox environment. The other one is a managed environment. The sandbox is more constrained. You have little knobs to turn on, and your flexible is a managed service, so you have more flexibility. You can bring your own runtime and easily deployed. But everything has to be web-based. It is still the same application. That app is the most important thing. It's always an app. It cannot be a database, basically. All right. Is this part clear, folks? Is this part clear? What are the two types of environments? I'm a great fan of App Engine Standard because it scales down to 0. And I have one small website. It is currently running on App Engine Standard. So I'll show you that towards the end. Yeah, is there a question?
Yeah, when it scales to 0, that means the entire application will be down, or it won't.
It will be in a state where it can you send a request, it's going to immediately provision a resource and serve you. So if there's nothing, it's going to scale down to 0. Basically, no need to have a instance running just for the keeping the website up. So never you will get a message that the website is down immediately, because in 30 milliseconds it can provision quickly. So you can easily do it. So that's the cool part of that. We'll see that in demonstration. Maybe next week, I would say. We can see that part.
Thank you.
When it comes to standard environment, right? There are a few more options actually. First generation and second generation options are available. The first generation, to be very frank, 2007 or 2008 till 2018, 10 years, 10 plus years, only this generation was there, folks. 10 years they kept only one generation, and there were lots of complaints. When are you going to support? In 2018, if you see, lots of languages versions were already there. They were still supporting the older version. Python 3 was not there. Java latest version was not supported. There were lots of drawbacks to the first generation, and they had some constraints also. Too much of constraints. You cannot bring a third-party library. Only the approved library, whitelisted library should be allowed. Lots of constraints was there, and it was not so easy. But with that constraints also, there are lots of applications people were deploying on App Engine. Snapchat, if you have heard of this chat application, Snapchat, so they were one of the early adopters of App Engine. So many people have used it, but this limitation was creating a problem. So in 2018, Google launched a second generation of it, where they provided support for latest versions, and they remove certain constraints. So you can bring any library, any third-party library on Java, any third-party library on Python, it's going to support. So the whole reason why they made this enhancement was the underlining container runtime was changed totally. So previously it was a proprietary product, which we don't even know what is that. But the second generation, they use something called as gvisor. This is a container sandbox environment. So if you just search for gvisor, you'll come to what is the runtime they use. Let me show you that quickly. Gvisor. So it's open source. So if I just come here, a container sandbox developed by Google and focused on security, efficiency, and ease of use in 2008. So if I just go here, yeah. So you see, let me just zoom this a little bit. gvisor is an application kernel written in Go that implements substantial portion of Linux system. It includes container initiative, open container initiative runtime called as runc. Heard this name somewhere, folks? Runc in our container class. Did we hear it somewhere? So there was a slide where we had there was a slide which was showing the various container runtimes. One was the popular one was our Docker. There was other few stuffs, and there was a cuboid and there was a hamster in that image. So if I just, yeah, not Minikube, not Minikube. So one minute, let me just go to that slides. containers snapshot. This one. Docker was one of the popular runtimes, Rocket, LXD, and this one was the one which actually are run C or run C or run S. So this is a hamster in a cuboid. So I had mentioned this is based on Open Container Initiative. What is that? Specification. Open Container Initiative specification. So this is based on that. So this is the mother of all container runtimes. So people always extend this and create a new container environment. So even gvisor is based on the same thing. So tomorrow, if you're going to start up a new job, a new company or anything, and you want to have something like uh, Docker kind of a stuff, you have to usually use extend this basically. So that's where you use it. So, and this is open source because of this runtime, it became very easy to support more runtimes very easily, support for more language runtime. So it was all because of this run C. Now they have an implementation that called Microservices. So some things which we saw comes back there. So it was all because of gvisor base. Now you may expect more support for more languages very frequently. Now 2018 till 2021, so roughly around 3 or 2+ years. So you see lots of language support, and I guess there is also support for Ruby. Now Ruby is also there. So more languages would be coming, and maybe in future even .NET can come. .NET may come. So maybe in you can use standard environment itself for deploying even .NET based application. That can happen in the future. So now let me just stop here and show you the screen, how App Engine looks. And because it's platform as a service, it's a serverless product. Nowhere you are going to mention, I want this much of CPU, this much of memory. I want this to be created in this network. I want this much of storage. Nowhere. You just provision, activate your app engine. Once you activate your app engine, that's a one-step, one-time process. You can provision, you can just deploy your application. No need to worry about any infrastructure part. Let me just show you that part. And this is the most important step, folks. Whenever you are doing an app engine, make sure precaution when you're provisioning this. I'll also share my own experience with respect to App Engine once I provision it. So App Engine, when you come for the first time, right, you're going to see a screen like this. Afterwards, you will never see the screen because the entire user interface will change. Create an application is what it indicates. Behind the scene, it's going to do some process. One of the process it's going to do is, because it's a new service, a new service account is going to get created. We know that something similar is going to happen for App Engine also. And App Engine behind the scene, as I mentioned, everything is code. So it uses Google Cloud Storage bucket behind the scene to keep all your code for staging purpose. So two things are going to happen when I click on create application. The first one, a new service account. Let me just show you what's going to happen. Service account. So currently I have these service accounts: compute engine service account, cloud build which we enabled. Those are things which we have. Then if I go to my storage, I have already two buckets. One was for my storing my containers. The one which got created for my cloud build, I can delete it. I don't need this anymore. I don't use anymore. So this is a current stage, folks. Many service accounts. 1, 2, 3, 4. That's it. Now let me go and enable my app engine. And this is the most important thing. I have done a blunder when I had done one implementation in a service account, service project, sorry, in a service-based organization. So what is that blunder? I'll explain you once I finish this part. So create an application. When I click on a create application, this is the most important screen. And please use this, look into these words. This is very serious words. Region is permanent. So once you decide the region, you want US Central fixed. In the entire batch 6 project, you cannot change it later. App engine is going to be in US Central only. It's not a Kubernetes engine. It's not like your compute engine. If you make some mistake in the wrong region, you have some various options like snapshot, all those things, or cardon, Kubernetes cardon options. You don't get that option. If you make any mistake in the region, you can recreate in app engine, sorry, recreate it in Kubernetes engine and in your compute engine. But when it comes to app engine, you cannot do that. So, and you have limited number of stuffs. Now, if you look into this option, what does it strike you, folks? So the region, for the first time, we are seeing a product in our learning, which is a regional resource by default. Compute engine is by default a zonal resource. Kubernetes engine can be regional or zonal. But first time we are seeing a product which is by default regional. You cannot have a zonal presence itself. It's a regional product. And you get around a few products, a few regions, 1, 2, 3, 4, 5, 6, I guess 19. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. How many regions do we have, folks, in GCP as of today? How many regions, folks? 24 is what we have. So we have only 19 regions here. So there are regions where it is not available. What are those regions? If you are interested, Taiwan is one, Singapore is one, and there is one in Europe, one in US. We show you those things. China, we don't have a presence itself. Forget about China. We don't have a presence itself. We in the sense, Tokyo, it is there. So I'll show you that. So if you go to your regions, So we don't have any data regions in China and Russia due to political reasons. So, but we have presence 24 regions across the globe, and specifically app engine is not. Compute engine, Kubernetes engine is available everywhere, all 24 regions. But app engine is not available in specifically regions like, if I go to Americas, app engine is not available in Oregon, number one. If I go to Europe, app engine is not available in Netherlands, Finland. Totally how many? 3 over. In Asia, it is not available in Singapore. It is not available in Taiwan. Totally 5 regions are missing. Per my understanding, there are some information which I got that in Singapore it's going to come by quarter Q2 or Q1 of 2021, but I'm not sure of it. So knowing this is going to be helpful, folks. Now, say for example, if you are going to do some implementation for a customer who's in Singapore, who is in Netherlands, who is in Oregon region, and if you prefer to use app engine, you cannot even provision it. So this question is not going to be asked in the exam because you cannot remember all these things, but it's not available in all regions. That is something which you need to be aware of. So deciding the region is very, very important. And once you decide it, you cannot change it. It's fixed in this entire project for lifetime. unless you delete the project, you cannot do anything. Very, very important. What I would suggest is whenever you have a requirement to provision App Engine, get the buy-in from the customer. Where do you want? If they don't know where to provision it, have a call, explain them these are the regions which is available. In which region do you want? If they ask your suggestion, you can give some suggestion, but uh, don't take your own assumption and do it. The reason why is I had done this blunder. So there was a company, it's a US based company, the Uber Eats example which I mentioned. They were in North Virginia. Where is that? North Virginia, US East 4. So what I did was I was pulled into this project ad hocly, and they told please deploy this because team is not aware of Google GCP, so they have the code. Can we have we have a demonstration of the customer? Do it. So just told the customer name. So I did not even ask further question. I thought myself I am smart. I did this. I just went to the website, searched for that customer name, came to know where is their headquarters. I understood their headquarters in North Virginia. So now what I did was I went into that specific dev project. Uh, Dev project. What was that? East 4. So it was East 4, North Virginia. I just created North Virginia and created the app, and they gave the code. I deployed it. Now it is all working fine. Now there was some testing team in Bangalore. They called me and told Mahesh, we are having a latency issues. We are having a latency issue after you deployed it. Now then I did not what's happening. Then I little analyzed it. Then came to know the problem was this one. Let me open up this thing. App Engine was in North Virginia, US East 1, East 4. And testing team is in Bangalore. And the funny part was the database was in London, folks. It was in London. I did not even ask this question. I simply deployed it, thinking I'm smart. I will not ask it. So then you can easily understand the latency why, right? Front end is in US, so it's like a round trip which you're going through. So it is like developers or testing team is in so it was actually in Bangalore or Hyderabad. So Bangalore, Hyderabad, database is in London, and your app engine is in North Virginia. So the round trip you will see latency acceptable easily. It gives an explanation why the latency is there. Now the reason why I explained this was I made a blunder. I could have asked the customer a detailed thing, and the team was also in a hurry, so I did not have much time to do it. So I just did it in a very crude way, and I was not able to do it anything. So because once you fixed it, that's it. You cannot change it. Even if you have the highest level of support from GCP, you cannot do it. The support team is going to say, please create a new project and create the region in the right region of your choice. You cannot get any support for that. So the only thing is when you're working on App Engine, get the buy-in from the customer. Write it in an email. Get where you want it to be provisioned. Luckily for me, even though I did a blunder, it was a dev environment. So what I did was a fix was exported the data of the database from London, created a database in North Virginia itself, and made it connect. From Bangalore, people directly connected to the app engine, which was in North Virginia. Now the latency was reduced. So lucky it was not a major blunder, but my lessons learned was to decide the region yourself. That to App Engine. With Compute Engine, Kubernetes Engine, no problem. You make mistake, you can recreate it. But this mistake is an expensive mistake. Okay, so make the region very clear where you want to do it. And since, as I mentioned, this product was the first product which Google launched, and when they launched the product, they had it available in US Central and Belgium, and only these two regions does not have a number, but it is West. If you see Europe West means it's Belgium, US Central means it's US Central 1. All other entries has a number. So it is a regional resource. and you cannot have any other option. It's always a regional resource. Now, what we will do is we can go with a region middle. So looking at the map, for me, it looks like I go with Belgium, it's going to be middle. So that if my website is going to basically get traffic from everywhere, putting it in Belgium is okay. Now, again, you may think of Earth at the end, it's circular. You can put it anywhere you choose. You think you can put it. I would prefer to do it in Belgium so that it looks, at least in the map wise, it is central. Okay, you take a call and you have to get a buy-in from the customer. So Mumbai also you can do it, but Mumbai has some issues. So I don't want to take a risk. Batch 3, if I'm not wrong, I provisioned it in Mumbai, and I was not able to show them the demo of App Engine. I had to do another project and show that there in that project. So I don't want to do it in Mumbai because some resource constraints are there. So I'm going to do it in Belgium region and create it. And this is the last time I can see the screen. So click on create. Things are going to get provisioned in this region only. Click. There's an optional step. So the region is getting create, App Engine is getting provisioned. Meaning you, so the language support. What are the languages? Node.js, those options. So if I have Python, I have two environments, folks. Support for standard is there. Support for flexible is also there. If I choose Java, again, I have support for standard and flexible. But if I choose .NET, it's only flexible environment. Or you bring your own runtime, C++, it is going to be flexible. All other languages have support for standard and flexible. And this is an optional step. Now let me choose .NET purposely, .NET, and click on flexible because later I can change it. But region, I've already clicked, it is already provisioned. Now I cannot change it anything more. So it is created in Europe, which is Belgium. Click on next. That's it. Your app engine has been successfully created. That's it. Now you cannot change it anymore. So there are some other stuffs which I'm going to do it later. I will do it later. Now you get sometimes an error like this. This is a known issue. You just refresh the screen. You may have the issue gone. Let me just refresh this. You see this? App engine has been created. Now if I click on get started, this one, cancel it. Okay, I have to click on here, folks. App Engine dashboard. I should be able to see this. Okay, let me just click on this something. Dashboard. Okay, dashboard will come up later. Dashboard will come up later. Dashboard. Okay, it's okay. So once we do deploy anything, it's going to come up there. Now App Engine is created, and it is created in a specific region which cannot be changed. What has happened to our IAM? Let's look into it. So let me just refresh the screen or go to a new screen and show you what has happened. Just 5 minutes, folks, and then finish it off. So if I just refresh the screen, this account is going to be this one. You see the previous screen? You did not have App Engine service account. You had 1, 2, 3, 4. Now, if you see, you have the 5th entry, App Engine service, App Engine default service account. It also has editor role. This is the first change which you see. The second change which you see when you enable App Engine is in your storage bucket. If I refresh it, you will see 2 more buckets automatically created. 2 more buckets automatically created, which is in Europe, because my App Engine is in Europe, West, Europe West 1, Belgium. So these are two changes which happens behind the scene, and your app engine is fixed in Belgium. It's fixed in Belgium. And if you want to know the details, you can do something like the UI it is not showing. I'll just use my command line to show you this and then stop it. So once we come back on next Saturday, we will deploy an application, and those demos are going to be so quick, and its demo is over. It's not like us, we are scaling, load balancer, all those things going to come so fast with App Engine, Cloud Run, and Cloud Functions. So let me just show you this part and stop it. Just want uh, and if you want to start a tutorial, you have the tutorial here. So if you want, okay, I'm not sure why today breaking of voice breaking is happening. Apologies. So let me see my connectivity. So 2 or 3 minutes, folks. That's it. We'll stop it. Okay, this is taking time. So stop it here. We know we're not able to show you the command line. I can show it. I'll show you that my cloud shell. So we'll stop here. No voice. No voice. Okay, 1 minute, folks. Let me see. Okay, so we'll stop it here. We'll stop. Okay, okay. I really sorry. What is happening? Stop it here. So provision our app engine. So next week when we come, we'll just into playing around with app engine. Okay, so we'll just stop it here. If you have any questions, happy to answer. You're welcome, Anil. Any questions, folks? And if you have a hard stop, you can log off, folks. No more lectures further, but if you have any questions, happy to answer. All right, okay. So people don't have any questions. All right, folks. See you tomorrow. Sorry, see you on Saturday, next Saturday, with us. All right. Thank you.